Hey, so this is Coffee Compiler Club. Anything to do with compilers and language runtimes and garbage collection and exceptions and typing systems, anything else. It's all fair game, language implementations. You're being recorded. This will show up live on YouTube in a couple hours. If you don't like that, bail out now. This is for Helix's benefit. And then for a bunch of people who've asked this, who watch the videos but don't ever see, if you want to join, you're welcome to send me a request, either via email at cliffc@acm.org, which is my same email for like going on 40 years now, or at Twitter at cliff_click, and I'll send you an invite. Okay, that was the end of my official spiel. Helix has got something in particular, because I just got a mail late this morning saying I wanted to do something. Did you want to bring up what you want to talk about?
Yes. Hey, I mean, I'm from a machine learning background, and I mean, from this point of view, I mean, the ultimate compiler I can imagine is, hey, I have a natural language description of some kind of things I want to do, and then the machine start coding it, and then launch the application for me. Right? I don't know if this is too, naive for this club. There's a couple of series of operations you need to complete in this chain of tasks. Number one, you need to understand the language. Number two, you need to parse the language into structured format, and then you compile that to some kind of runnable or some kind of applications, right? So I want to understand, in traditional compiler field, is there any kind of technology to help you deal with ambiguity?
No.
No?
No.
Okay, so everything should be very well structured, and then go through a compiler and then do
Yeah.
right. I mean, is there any kind of research in
There's
that
tons of
space?
research, and the answer is always the same. Unless your problem is mathematically well defined, the computer has no common sense. So he doesn't understand what your intent is. He can only go with what the mathematics say. and that boils down to, you got to be mathematically precise. You don't have to write it in C or Java specifically. Oh, maybe it's Scala, maybe it's Fortran. SQL. Outside of this narrow domain, you don't get a well-defined problem, and the computer has real trouble filling in the gaps. So Cameron pointed out, so you guys don't know there's a history. I got an email from Cameron saying this guy was trying to solve a set of problems. There are some natural language processing things going on. Oh, here's Cameron now. That can
There you go.
add some amount of meaning to things. There are certainly efforts that have been said go to SQL queries from natural language. These are all sort of very narrow domain problems where they take a natural language problem and try to express it in something else. Usually it comes in front of the user anyhow, who has to clarify, because the computer, like I said, has no common sense. So if he doesn't get it, he doesn't get it. And you can ask him to guess, and his guess is as poor as what you'd expect a 3-year-old to guess. Has no clue what you're talking about.
The best you can do is a Google-like interface. I write some piece of code and I get something back that says, hey, you gave me ambiguous input. Here are my 10 things that I think you're most likely to have wanted. Click one of them and I'll replace your ambiguous thing with an explicit thing.
I mean, imagine that kind of interface, also somehow can show up in the compiler. For example, hey, if you write a Python script and then you call a function and you forget about a bracket at the end, and or is that reasonable? Go ahead.
Well, in the narrow domain of determining parsing of a otherwise well understood programming language, where your goal is to accept an erroneously program that has modest typing errors, modest syntax errors, there's a lot of research on best effort, where to put the closed curly. This is not a general purpose solution under any means. And it can be just as wrong. So really they turn into, here's a suggested fix, not here's a fix and run with it, because usually it's not actually got the fix.
I see. So, I mean, you talk about the narrow thing, about closing bracket, those type of use cases. Any kind of advanced research, any resources to read about that?
Every compiler's error handling on the planet, I would go to Google Scholar and say, error recovery and compiling
You can
languages.
say, yeah, parsing, recover,
Parsing
parsing.
recovery, yeah.
Yeah.
Oh, okay, parsing
Parsing.
recovery. Okay,
Yeah.
got it. Already.
Parsing error recovery.
But you'll find that this is like I said, it depends on the structure of the problem in order to be able to solve it. So it's a very narrow domain. I know that the goal was to not have any errors. I suspect the following errors are common. I'll try each one of these tiny little fixes in a turn and see if I get fewer errors back when I'm done parsing. Kinds of approaches. That's the mindset going on.
I see.
There's no understanding of the programmer intent. It's strictly, if I stick the closed curly in here, I got this pile of errors. I'll stick it here, I get this pile of errors. Okay, I stuck it here, I got fewer. I have some other errors over here that maybe cascaded from this one. Now I'll stick some in, blah, blah, blah. There's some effort to minimize, but
to be fair though, the with some of the AI stuff, like
so back off from AI as a
I'm using it in
term.
quotes for a second. Yes, okay.
So machine learning.
Yes, so if you look at what not Bitbucket, but GitHub is doing with their open source theft, I'm sorry, with their machine learning based open source theft. I mean,
we got it.
Completion. You could imagine that same technique would actually be far more likely to be able to balance parentheses, for example.
Yeah.
Than the traditional approaches, which is what which is what I've done in parsers in the past, where you're basically trying to figure out how to seal off a region of the code that has an error, so you can move on to the next region. So you only try to detect one code error within a region. And then, so if there is an error, like let's say it's a balanced parentheses or curly or whatever, you're basically trying to guess by looking at the structure of the language, typically looking for particular keywords or something like that, where you can safely pick up from a clean state. The safely being everything's in quotes, right? Because it's all a guess at that point.
The problem being here, the guess wouldn't be sustainable, wouldn't be reliable. If you wrote some parser recovery program, it will treat it as a spelling mistake. It will try different combinations, but you always can deduce what part of the program did it took to solve the problem. But the AI is much more a messy problem. It can you can't always you can't guess most of the times what the decision was to be made for the parser recovery. So I believe it can be made to work because here is a narrow domain of the problem to recover just for the parsing error. But I believe it will essentially lead to an errors if it has to guess too many things. It will try to make it correct, but it wouldn't be correct because
there's always a chance he gets it wrong because he can't, the compiler doesn't have any notion of what intent is. So if you're indenting your program and you skipped a curly and it's an indentation optional language like C or Java, you can use an indent as a programmer intent and then guess the curly goes there. You're doing the same thing in Python? No, it means something different. So it doesn't work.
With the advent of this Copilot GitHub program, who knows? And maybe it will get it to work.
In simpler, in parsing CSV files, so I did a big data startup, and we would have CSV files that were megabytes, gigabytes, terabytes for a single file. You would have errors in the file all the time, and but the structure of a CSV file is much simpler than that of a regular C program. So if you're looking to guess where a line in is, or you're missing a comma for a field break or whatever, it's way the hell simpler to recover to say this line of data is probably corrupt. I'll do something about it, flag it. I found an obvious line in somewhere. I'm starting up again, and that's part of Cameron's solution. I bounded the region of badness and carried on with life. But that's because CSVs are so simple. Programming languages way more complicated. Natural language processing far more complicated. No context. So
I'm curious if you've looked at Wolfram Alpha at all.
I've only,
So Wolfram Alpha, you can put in a query and be like, what is the distance to the moon
yeah,
divided by a foot long
yeah,
barrel,
Google,
whatever.
right. Google query does that kind of stuff too.
And it will make a guess and be like, here is the snippet of Mathematica that I think is vaguely related to your sentence. Is this roughly what you're going for? And it will do reasonably well. And then you add one more character and it suddenly shifts spectrum entirely and is like, do you want a
Yeah.
stock quote? And you're like, how did I
That
get from
was-
physics to a stock quote? Oh, I put two symbols next to each other that are also the stock ticker for a company.
Just about to ask this question to Cameron. Which one would you choose? Reliability in error recovery, be it so few errors that it can recover, or recovery that you cannot deduce how the recovery decision was made?
Well, I'm not sure I totally grokked the question, but I have gotten less interested over time in error recovery from compilers. So this is, maybe it's a learning experience, or maybe I've gotten lazy. So when I did the Java compiler years back, I did full recovery, what I called expurgating. So it basically means like jump over the junk and get to a stable spot, right? So you expurgate your token stream until you have a kind of a recoverable point. And that's my dog whining. And it was handy, but really what we found over time is that most of the time when you have that first mistake, like it's best to cure it. Like even though there's a kind of repetitive cure one and repeat, the signal to noise was dramatically better. How's that? Cliff, I saw you nodding the whole time. So you seem to.
I've done a lot of compiler recoveries in my day, and the answer is pretty much, yeah. The first error is key to report nicely and well.
Exactly.
The remaining errors are much less important because there's huge odds that you're just screwed up from the first one.
Right.
So a convenient, nice, best effort thing, but do not burn your life trying to get perfect error recovery, because you won't.
But
it's not worth it.
I'd also say that different languages I would have different answers for. So for example, in Python, I would take a different approach, which is because of the indentation being so significant in Python, your ability to detect a point in a token stream based on its indentation that is likely to have sealed off the catastrophe that you detected is actually fairly good. Where your typical C developer doesn't know how to balance their indentation.
Used indentation in C compiler to close off a missed curly, but I haven't tried it in Python. It just looks like it'd be more disaster, but it's an obvious end of indentation. Yeah.
Now I've wanted to try it in C family languages and haven't, just because of the different code styles with the different balancing of
the indentation one is sort of the easiest of them all to solve. The next one is you blew some typing thing and the type cascading failures flow forwards, and you mistyped an initial variable, and all the hundreds of uses all want to complain about the mistyped variable. Compiler happily grabs a nearby one that's only off by one in a spelling, but it's the wrong one. So he's all typed error after that. Anyhow, also, and on it goes. It's sort of not worth it.
Yeah, last week we also joked about the whole IntelliJ. I typed one character and it takes the rest of the file and puts it in red slowly. And
takes 10 seconds and spews it all red, and then you correct the one character and you finish typing. You haven't even finished typing, and then it's
so. Helen, if you look at there's this concept now called a language server, and I hope the term doesn't stick because it's a horrible term, but it's this idea that the data structure behind the code that you're working on is already parsed and some level of munging and whatnot, sitting in memory somewhere. So every keystroke you make is like a request to that server saying, I did this. It's like it's kind of
wants to do an incremental update on a AST.
Right. Yeah. Right. So I think that style as well introduces some new. We talked a little bit about it actually last week, I think. where the idea is, and I'll just give the idea, don't take this as gospel, just more as an example. So for example, you open a file, it's okay, right? So the language server would do the same thing. It would say, okay, I've got this brace matching with this brace, everything looks good. So I'm gonna remember all that nesting. I'm gonna remember all those scopes and this nested scopes and so on. So when someone starts typing, I'm not gonna recalculate the scopes while they're typing, right? I'm gonna keep those scopes as kind of given boundaries. So if they don't mess with the begin or the end of the scope, whatever they type in between, I'm gonna localize the focus of my analysis to that one area. And that would solve like the IntelliJ problem, for example, that we're describing, where it picks up on the fact that you type an open curly and it's like, okay, where's the closed curly? And then the rest of the file looks like garbage because it's almost reparsing the entire file on every
Well,
piece.
it clearly is, because it just rolls down the side, painting. I can watch it in real time. It's like fucking slow.
I mean, the language server, I mean, I know some of the server used for, typing hint, right? If you type a call API, it tell you, hey, what's the parameters you can put in. And then, but, make it more advanced. Hey, you also, for example, if I import a file, maybe the server can grab the file content, make sense of it, maybe grab some keywords.
They do. That's already going on.
Oh, I see. What do you mean? Do you have any examples? I mean, I can search.
Oh, IntelliJ just parses all your pound import, pound includes, import, blah, 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 so that he can do completion on you. So you can type a little bit and get completion. My fucking Emacs does that from, programming language / editor from the 60s.
And
I can
even
totally partially type things into Emacs and have him autocomplete from all files nearby.
And even can tell you what's the types of the arguments it accepts. So
Yeah, yeah. As soon as yes, and then the next thing he does is he says, I parsed it. I got the types as well, and so I'll give you the type hints and the arguments. Oh yeah. Emacs is not doing that part, but IntelliJ certainly is, and it's from files that are nearby, and a lot of files that I've never touched, never used in the RT.jar or whatever. So I get all these completions for things that are unrelated to anything I've ever done, and will never ever type it. So that's very annoying. Where Emacs is better about that one. I don't get bogus completions all the time.
Interesting. The Emacs is run local, right? It's a thing you can install. I mean, you run your local. Okay.
Yeah. It's an editor. Like I said, it's a fucking editor from the 60s.
Yeah.
It's a really powerful, really good, well thought out, blah, blah, blah. Okay, you're an Emacs fan or you're not. That's the kind of, programmers all have the in-joke. Your Emacs or your VI. Yeah, fine.
Saying it's an editor no longer means it doesn't touch the network, though.
What happened
It's
to
kind of a
cat?
windowing operating system in an editor, because it windowed before Windows was Windows, and people loved it and used it. So yeah, two-dimensional drawing platform, game writing platform, windowing OS, and a standard single-threaded yada yada Lispy running program from the 60s. Fine. Moving on past Emacs.
On the topic of unbalanced braces, I'm wondering if anyone tried involving some, let's say, temporal aspect in dealing with it, saying basically, okay, you wrote an opening curly brace here, but I as a compiler or I as a language server or whatever know how the code looked like half a second ago. I know that the code was correct before, and adding an opening curly brace means you're not finished yet. So I keep the old state with me, so I can actually tell, okay, you're writing code there, the curly brace is probably ending up somewhere in this area, so I don't need to reparse all the remaining stuff.
Yes.
Does anyone know whether?
I've certainly used such systems. I've seen them. I haven't.
I have shared
them.
a video of incremental parsing that uses this kind of techniques.
Yeah.
In our previous discussion,
Yeah,
search for
and Cameron was just talking about that. The same thing. Yeah. You have a
Yeah.
notion of here it was what it was. The
trees. It's
small
very
edit I did probably didn't fuck it all up. So let's bound the badness region.
Okay,
trees
so
uses this kind of techniques. Go ahead.
because the only thing I saw, or the only thing I know, is that there are people use heuristics to deal with this issue, and yeah, it
Yeah.
also seems to work. So I was just
No,
wondering.
that is a heuristic. The heuristic is I have an AST. You edited somewhere in the text bounded by this scope of an AST. Probably everything outside that AST is unharmed and unchanged by your edits. Even if I can't reparse within this AST region and get a sane parse, I'll just assume that the fuck up's in here and not out there. That's a heuristic.
Yeah, I'd say that's like it approaches the problem from distinct angles. One is saying, okay, I have this badness here and I have some heuristic to limit the area in which it does damage. And the other one is saying, okay, I know the previous state of the file. I don't
think those are
need to...
now you're the same. The difference is no difference, makes no difference. But heuristic's just an algorithm that's not 100% accurate. It's fine.
Yeah.
These
kind of techniques, these kind of techniques drop down the reparsing to a microseconds or 10, 100 or 200 microseconds or even less. Of huge files. And of course, the first parsing is linear, but the parser have to parse it first. But
it doesn't have to be. Damn it!
Why?
Fine, but it is. You're right.
Yeah.
I proved that I can parse CSV files in parallel, despite the fact that they have linear structure. And I know damn well from that experience that I can parse almost any language.
The parsing time is linear proportional to the length of
proportional size of the file, but I could divide by the core count of your parallel core.
That's fine. You can do that.
This goes back to the only purpose for MapReduce, which is to count words in a file, right? Like you basically with chopping a CSV file into blocks, you're basically doing the same thing, except in spaces. Instead of spaces, you're using CRLF.
But here, with the CSV, you exploit the fact that each line is its own CSV record. There has nothing to do. There is no dependency.
Yeah, hang on. So the difference here is that in the CSV, I'm exploiting the fact that I have a reliable terminator where I can repick up my parsing. I only need a statistically reliable terminator in any language to repick it up.
In programming language, this could be a module boundary.
It could be function boundaries, but it didn't have to be. It really doesn't. I can stop parsing at some particular end of an AST tree in the middle of an expression. Somebody else has begun somewhere nearby, realizes in the middle of expression, they build up something that's probably what's correct. Then there's an edge abutment problem where you line the two up and suddenly you get a fit and you say, from here on, the second guy's correct now. And everyone knows that until you get the abutment solved, you're not sure. But once you solve the abutment, you got it. And then it's more complicated to do a tree abutment, which is what an AST tree would be, but you could do it.
The trick would be
tree step one, it's much easier.
The trick would be to pick a section of the file that is not dependent of the other, so you can parse it completely independent.
No, that would be.
This very much reminds me of the fast adder.
I'm sorry?
What?
It reminds me of the fast adder. Early ripple carry adders, you had to take the carries all the way. And eventually they're like, well, if I chop it in the middle, either a 1 came in or a 0 came in. I can do these two in parallel.
And then you get the log tree version, which is what I'm talking about.
Yeah.
That was necessary to get 64-bit processors.
Yeah, I just needed to get the tail end of tree from guy 1 and the start of tree from guy 2, and the start of tree from guy 2 is fucked up and he knows it. And the tail end of guy 1 looks for a match on the tree 2 that got correct at some point. It doesn't matter where it got correct, and then you stitch them together and you're done. So there's an edge corner you can repair on, and it doesn't have to
throw out some work though.
I'm sorry?
You're more likely to throw out some work though. Yes.
The more unpredictable things are, the more likely work is to be thrown out. So my wife's over here trying to see how many people got their shirts. I'll talk about it. Da-da-da. Several people reported getting them. I didn't get sizes right for some people. there's some redo, but if you,
I would have to wait for mine.
yeah, some people, because if people overseas is gonna be slower. We paid money, yours was the worst, Theodore, but
I will repay it. Just send me.
don't worry about it. The guy in Australia, I forget his name, I'll have to look it up here. His was gonna be a lot worse, but the Damon Haley, yeah, but the post office guy said they've stopped sending it on the, first class, US first class, try again next week and maybe they'll start again. Otherwise, pay $70 to go to Australia, which was way exceeded what I paid to ship to you, Theodore.
Yeah. Well, send me the bill. I will send you the money. No problem.
Yeah, well, you're below the threshold that I want to screw with. It's fine. And it took me 15 minutes, 20 minutes to get Western Union to pay up. It worked, but it's like annoying. Okay, no, fine. All right, yeah, I screwed that one up too. Fine.
Okay.
Don't worry about it. But it's in the mail, and if you don't get it in the next week or 2 weeks, you should tell me, and we'll go start tracking it down.
I will get
Well,
it.
congratulations on convincing Western Union you're not an international scammer.
Yeah, that was. I tried to set up. What was the payment method? They asked me to install a bunch of programs. They then didn't accept my card and blah blah blah. That's why I would say I got emailed Clifton and said, "Would Western Union be okay?" Because
yeah, right. And I thought, oh, okay, fine, I'll deal. Whatever. Next time, send me a check.
Yeah, well, I don't know how to send a check.
Wow. All right, fine. I don't care. Not enough money to worry about.
Yeah. Not yet.
No idea when the last time I used a check was.
I use it every month. Fuck, I got half my bills online, half my bills. I write a check.
Cliff, I haven't received your package yet.
Did you send me a request for one?
No, he thinks he's being funny.
The mail's not coming right now because of the war.
Aren't you? Oh, you're on the International Space Station or something? Yeah, fine. Are you going to be the stuck astronaut? I heard about that guy. Like, really, Putin? You're just a dick and a half. Fine.
Oh, I finished my JavaScript version of the spreading hash function, and I uploaded it to GitHub.
I have a miserable hash function, so I don't hear do AA update. So
there's something interesting. I will throw it the link. You can play with it. You can write actual JavaScript to see how good it will spread the function. I maybe share my screen to example.
I get it. I got it. I got to hit the button here.
Oh.
I think that did it.
Yeah.
Oh, I'm screen sharing. Let me stop my screen share. I'm trying to get you to be able to screen share.
Okay. This.
Can you screen share now? There you go. There you go.
Did we screen share?
I did. I have it.
Okay. So this is kind of look like. If you refresh it, it will automatically build you the primes, which looks kind of cool. So here I found a bunch of functions.
What is it computing?
It's computing the hash point, which is I will show it here. It computed the hash point, and this point converts it with the Hilbert mapping to a 2D point on the plane. Okay. So if I clear it, it looks like no points. It looks like just a gradient. So if
you can pick your hash function.
Yeah, you can write your hash function, and
no. Pick the string one.
The string hash.
Yeah. Let's go look at some of these.
This is how many points, because you have you are limited by 5th to 12th by 5th to 12th.
Yeah. Refresh the screen.
This will fill the screen 40% and evaluate it. And this is kind of mapping of the function. You can increase
a lot of so areas which still have color are like areas where the hash didn't land at all.
Yeah, that's absolutely correct. If you can clear it and fill it much more, and this techniques is to look at how good the hash function spreads.
Right.
It's not a technique to find the collisions. I have said it here.
So pick a different hash function.
Yeah, the primes are really cool. I don't know why why they are, but they're really cool. The prime function is really interesting because if you execute it, this is it's like an interesting pattern. But the interesting thing is if you force the hash function to fill all the points. If you have a perfect hash function, what do you expect?
Black,
you have
right?
Yeah, and it's black because this is this hash function. Where is the prime? This hash function, this little hash function is based. I found it on the internet. Is based on the prime numbers, and here is a XOR to spread it more
do
uniquely.
some parens so I can tell order of evaluation in JavaScript.
Why
are you not parenting your ZORs with your multiplies? What are you thinking? Is it left to right for multiply versus ZOR?
I don't know if it should be this one. I don't
Otherwise,
know.
you pre-compute that one. See, that was just a pre-computed number, and then just write the constant down.
No. It takes the input.
You put parens around 1, 2, 1, 4, 3 times 89. The compiler recomputes it to a constant. I can tell you what the number is on my calculator. And then you can replace in the code. So I'm thinking it doesn't. I'm thinking it goes left to right, but I would have said parens on a ZOR because I have no clue.
Okay, I don't know.
Helix's question. Hey, what's the intent here? Well, fucking, I don't know what the intent is. The language spec says X. If I go read with my eyeball says Y. What are the compiler going to guess it's going to be?
Yeah. This is, I don't know why this function, but this is the only function that can maps all the unique points from one to all to unique places. So it follows.
That's wild. I can't imagine that little thing is actually 100% dense.
I don't know why is the case. I'm a little suspicious and skeptical that but it is the case.
I would be more inclined to believe that you are overcommitting points. And that the other hash functions are so bad that they stomp the same point over and over again. You have many collisions. I
have a little modification of the function which would tell you if there is a collision because it can check the pixel if it's black and make it a white. This would mean a collision, but it can detect it only once. So with collision, okay, this function, this functions. It will take a lot of time to compute, but it always compute the black. If I overcommitted by, let's say, 1%, if I overcommit the function, and you will see.
Then do the string one with the collision.
Okay, this and
okay, fine. Yeah, it looks like a good. Yeah. Okay, now I'm gonna do the string one. I want to see just how many collisions he's got, and you can go back to 100% instead of.
Okay, this is 100%. This is with the collision. This is let's put player and what do you
101 doesn't matter. It's still evaluating.
I will lower it.
You need a
well,
fine. I just could do the one and let it go. But why is it being slow? It's like time to go reprogram this in Java to the JavaScript.
Yeah, it's just
spit this out heartbeat.
The Scala native version.
Too many L's in your collision.
That's so.
Is that? Do you need an I? How are you spelling collision?
You
need an I in there. COLLISION. You're missing an I in the string one.
Oh, okay, cool. Oh, yeah.
Welcome to the land of strong typing and why we all love it and hate JavaScript because it doesn't have it.
Yeah, there it is.
Oh, look at that.
Yeah, but you should take this with a grain of salt because there are so many points there, so many points, and this is the collision. It's not necessarily the collision of the hash function, but it's the collision of the Hilbert mapping because there are so many pixels.
You just have a hash table with a fixed size set of buckets, and you land multiple hashes in the same bucket, which is perfectly reasonable.
Yeah, that's probably what is happening and it can show you the collision. I play with it with a few days, and I believe it's cool. That's why I share it.
Yeah, and right.
You can execute the actual. You can write your hash function.
Right. I was like, go run the Bertle.net one. See if he has a better spread on your strings.
Bertle.
The other one is you can pre-compute all your strings and put them off to the side in an array.
Oh, okay.
As opposed to making a string, 100,000 times there.
Yeah, we should mention the more random you look the function, it should look like noise. This is completely random, and that's why it
I
looks
would
like
claim
noise.
that's not very random looking random. I see all kinds of vertical and horizontal lines.
Where do we see it?
Well, what I see is a texture pattern like a cloth, which
Mhm.
tells me that you're repeating horizontally and vertically at some
But to be
frequency.
clear,
Yeah,
random is not random.
The
So
random here is
random int is pseudo random.
yeah.
Well,
that-
that's right. I understand it's pseudo random. I'm saying you have a bad pseudo random generator.
yeah,
Now
that's
go look
that's
up
fine.
what that generator is, because the
Fairly
original
good.
Java
That's a
pseudo
fairly
random
good
generator
distribution.
was
There
so
is-
bad. Hit
Here it
random
is.
int.
Here
right?
here it is. Yeah.
Oh no, here you go. Min, whatever, floor mat, what? Math dot random.
Yeah.
We've capped it to, right, okay,
Yeah,
so
that looks right.
Mm.
math dot
Yeah.
random return you a double and your
Yes.
scale.
Yeah, and I took the floor, and that would round it to a whole number because it's a decimal.
Yeah, right.
I'm
Yeah,
I
not
don't
the
know what
perfect.
JavaScript's math dot random does.
Yeah, I'm not the best JavaScript guy, but I just wanted to make it work. Everyone
Yeah,
with it.
because Java's original one was super bad.
If you overcommitted, you're absolutely right. Let's overcommit it, and you will see a straight lines of vertical patterns to emerge. Did you see them? Yeah, you now can see because there is
Yeah.
the random function is not perfect. But
Let me throw a piece of code into the doc here. I threw out on a Twitter. Like my first tweet was something like this.
mhm.
Da-da-da-da-da.
Mhm.
Okay, so what's the expected print here?
The random bool. The sum, I don't know. I can.
500.
Right. The expected value is 500.
Mhm.
Right. The actual
Oh,
value
it's
is,
it's 50%. Yeah.
yeah, right. The actual value is 0.
Yeah.
Because 100% of the time, the first 10,000 Java randoms are all have all the same patterns, such that when you mask off the bits for the bool, it's always false.
Yeah.
And this bit us at H12 because we would use math.random for Monte Carlo simulation kinds of things, and
Mhm.
promptly discover that the distribution spread was miserable. The first few hundreds of randoms were responsible for distributing data around the cluster and shit like that. And you get horrible distributions left and right.
Yeah.
Because the first 1,000 values out of math.random
Mhm.
were highly non-random.
Yeah, that's fine. So this is, you can play, everyone can play with the function. This is, I wrote it, so it would be interesting to, if you have a hash function, just to see how the distribution.
Let's grab the one from Bertle.net.
Yeah.
So I spent all week sorting on my bad hash. Last week I talked about, a week before we talked about the bad hash issues I had. And somebody said, hey, why don't you just do the strongly connected components, all get the same hash within and whatever. So I finally decided I was going to bite the bullet and do it the official way. Oh, there's a pretty bad looking hash.
Yeah. If it's one that is generating to that many points, if the function is perfect, then it's all black. If it's not black, then it's definitely has some
color leaking through. Yeah, I would love to see it with the collisions as well, because that'll tell you something else.
I have to point out the collision it can detect only one collision. If you check the pixel is if it's black, then make it white, and if it's the next time if it's white, it will make it black. It doesn't remember more than one collision.
Oh, it flips back and forth. Oh, you don't stick it white.
Yeah.
Oh, I see. Oh, that's more trouble. I'd love to see it just stick it white, because that'd tell you 2 or more.
Yeah, I probably can do it.
So start with a white background and do a heat map.
Yeah, basically that would be the next thing to go do, because the original hash I had, because of the bad quality of it, because of lack of information, because I couldn't deal with cycles, turned into a fair number of people with the same hash, and then some of the reprobes were getting into 20s and 30s in the hash function. It was pretty miserable.
So it's an interesting thing that Star you say about the Java random, because in our base class library for coherence, one of the things we did was the first time you ask for random, we would seed it. So we wouldn't use the Java random directly, provide and so we'd seed it with date time, but then what we'd do is we'd ask for a random value from it, and then we'd do some number of loops based on that random value, asking for other randoms. And it was, and the reason was because we had seen this bad behavior. It's like, so you spin it a certain number of times.
The high order bits don't get any data in the original math. I think they fixed that some time ago. But in the original math random, the high order bits in the seed wouldn't get any data because there was no way to set them directly, but they would get filled in from low order bits as you executed. So if you took a current time millis to seed it, the high order random bits were all 0, the low order long was filled in. Okay. So now if you run some number of iterations, if your some number didn't run enough, you still wouldn't populate the higher order bits, and you still had this highly redundant hashing thing. I mean, random thing. It wasn't good until you got more bits up there. And like I said, I believe they fixed that. Certainly in H2O, we ran through like 3 or 4 different iterations of a random number generator. We wanted pseudo-random. We wanted one that could jump forward in time so we could hand off billions of random numbers to individual nodes in a cluster. So they would have to come back to the mothership to ask for random numbers to the next random seed. You could be deterministic and say, you, Mr. Node, here's a billion random numbers, and you, here's a different billion, a different billion. You'd hand them out. And they would recursively hand out internally with that. They'd break out their trees. So an individual log tree breakdown of a terabyte, every individual line in the data could get a random number without reference to anybody else at the time he was doing it. So it was a lot of work to get these deterministic, future-looking random. But then there's papers on it. There's algorithms out there. You can do it. It's a thing to be done.
Okay.
But it's not a naive thing. You get a crappy answer if you do the naive way.
I will stop screen sharing now. No.
Yeah, fine. No, it's pretty. I like it. I mean, it's a fun way to look at the quality of a hash function. The other piece of that, of course, is like Cameron said, put a heat map for collisions. My problem was I have
how many collisions happened within.
Right. My problem is I typically have small amounts of data that are all very near each other. So individual bit flips really need to spread. And if they didn't spread you, because I was doing XORs instead of linear.
That's the worst case. If they're slightly different.
They're slightly different. Yes, they're all near each other. Slightly different. They didn't spread at all.
You want to combine XORs with rottles or rotters.
Right. Yeah. Exactly. I was missing the rottles and rotters. Yes. And that was leading to really bad hashes. So I've sort of biting the bullet the hard way and doing it the right way, which involved replumbing one of the oldest parts of the type system, which was the hashing computation, which meant that I've been all week at cleaning up code and rewriting, and I have
a couple of people joined, so I wonder if any of them have any background on Helin's earlier question.
Oh, yeah. Helin, you want to restate for other people something short about what you were just talking about?
Yeah, I mean, I would try to understand how a compiler dealing with ambiguity, right? And from a background that I want to explore the space that how to translate a human language to a runnable application. So if anybody have some ideas, we can discuss about.
Programming languages are human languages.
That's true,
but they don't typically deal with ambiguity well, or at all. They're actually also pure mathematical entities. The standard programming language is purely a mathematical entity. That's part of the issue here. And we've had people comment on, I've seen NLP to SQL queries, a lot of queries, natural language to queries have come around in a lot of contexts. That shows up. That's not an application.
But this can be a milestone towards a bigger thing.
Yeah.
And
the issue with the
go ahead.
The issue with the query is that you don't expect it to be correct, and you don't know what you're going to get for an answer anyhow. So close is good. Horseshoes and hand grenades, close is good enough. Whereas the typical issue for a compiler, same as for a computer, is perfection is required or it's just wrong. And so the usual behavior of wrong is it crashes and doesn't do anything.
Let me paragraph it, see if I understand it correctly. So you say query language can be done because it's not error prone, right? It's there's some
No,
kind of-
it's error prone to hell. Is it's error tolerant.
okay, all right. So I mean, this you should expect people to correct that kind of query, to correct that result if they see anything wrong.
They
But,
refine and go again. Yeah.
I see. I
Yeah.
see.
So what you can expect out of this sort of approach is what I usually call power steering.
Mm-hmm.
You give somebody does something, you take that and you try to give them enough information that they can act on it and go again. And the effort to do any project where I guess and compute an answer, like I did a machine language looking for fraud in the stock market. So machine learning. The act of a computer declaring something as fraudulent, full of bugs, often made mistakes. Okay, fine. So I wanted to give enough information that an expert could look at this transaction and actually had to look at the history around it and all things in context and decide it was fraudulent or not. And then that fed back into the machine learning models. So this is what I would call the power steering. I thought this was fraudulent. I had to give it off to an expert, but he couldn't look at it by itself. He needed all this context. So I also came with it. Here's all the nearby transactions, and here's related things, and here's a movie player that runs the transactions in real time in 1/10 time and lets you step forward and backwards, and here's a layering in the stock market, and here's the current active trades, or blah, 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 thousand other things. And the guy would surf around in the nearby data, deciding what it meant. So I empowered the expert, who then gave me an answer, yes or no. And then I would go recompute my models based on the expert input. But the effort to get from, I got you an answer, this is fraud or not, to I could feed it to an expert and he could validate what I said is like an order of magnitude more engineering effort.
What you mean is soon after we have a place to plug a human in the loop, and the
As soon as
magnificent
you plug a human in the loop, it's 10x the effort.
Right.
So I can take your language and you say something. Please, sir, give me a thing which tells me the cheapest place to buy gas in the local area. And I'll come up with an app and hand it off. Okay, you run the app and it crashes. Or you run the app and it tells you where the best place to buy bread is. Or it tells you only the nearest gas station ever, no matter what, or whatever, right? It does the wrong thing. You have no way to understand what it's doing except by guessing. You can't correct it. Okay, so now to go to, I said this thing, give me an app that does the following, and I gave you something that was in that direction, but maybe wrong, and now you could begin to correct it or understand what it's doing. That's the 10x magnitude increase in engineering effort. For you to understand it and then to feed it back as well. Like the feedback problem is also non-trivial.
Yep. So typically when people programming, people hope, hey, I read my code. If nothing happens, you run through a compiler and everything should run exactly what I'm doing.
Yep.
Right. So
just to be clear, everything runs according to the mathematics of what I said, had nothing to do with my intent.
Right, I see. Yeah, anybody, really have done any kind of work and from the natural language to query, I can follow up and drill a little bit deeper about those kind of.
I've done some amount of NLP, but I am not the great expert. I've done word to vec and I've done related query things. I know of people who've done this. You want an NLP expert if you're going to go to the query side.
Right.
Yeah, someone from Google Translate, for example, that would be an interesting one to look at.
Translation is another problem that's been studied really hard for a long time. And again, close is good enough.
Right, because with translation, what you're trying to do is build an independent model that you use as your IR, right? And then you have one language here, it goes to the IR and then comes out to a different, so you have kind of a shared
IR is
model.
Shared meaning, but
internal representation, by the way. When he says IR, intermediate or internal representation. It's some other form that is a mathematical description of what was a pile of words or descriptions or something on this side. I have some meaning, some semantic web, whatever you want to call it.
Who's the crazy language professor who's got
Chomsky?
ridiculous? Yeah, Chomsky with his San Franciscan views.
Yeah, right. Well, I mean,
Chomsky is the other guy to look at in terms of the, or at least
still kicking around.
I think so. He's still making Republicans mad.
He's a pioneer in the work of our regular languages. Yeah.
Okay. Wow, I figured he'd been dead old age by now.
Noam Chomsky it's involved in the creating of the BNF, the Bacchus norm form.
Yeah, Bacchus North format and stuff. Yeah. I gotta go ask this one here. Oh God, he's got quotes on. Yeah, he's not young, but that's what the hell? You think he's alive? 1928. He's born 1928. What the hell does that make him now? I can't do math in my head.
He's over
almost-
90.
He's
Over
almost
80.
as old as the last two presidential candidates.
Wow.
I wanted
Hey,
to say,
Okay.
two ways to write a parser. There's like the LR parser or idea, where you say like there's only one valid parse for a given program, and like it computes the LR table, finds that parse. And then there's like the context-free approach, where you say, I have this grammar and I'm going to compute all valid parses of the grammar and whatever, and then I'm going to sort through all these parses somehow and disambiguate it after the fact.
See, I think already you've gone to the zone of I have a mathematical description. It treats ambiguity in a mathematical context, actually in a very limited way, usually for the context-free grammars, to do the disambiguation. But there's a very narrow, specific meaning. Whereas I heard Helix say, I want to do natural language processing and produce an app.
Right. So natural language processing, you have probabilities, and that's what you use to disambiguate the parses. As you say, you still have to go through the query or the input and say, oh, it could parse this way, or this way. It's just that after that you say, oh, well, it's this parse has 0.01% probability, so I'm going to ignore it.
I still think we're the issue here is there's no common sense in a CFG grammar's disambiguation. So the natural language processing starts with the assumption of I have common sense. I don't expect the moon to be made of green cheese, right? So when I parse something and build something out of whatever I'm doing here, I'm bound by the limits of not understanding what the fuck I'm doing, right? And in the case of a natural language query, I'm kind of sort of saying, I'm going to take your written description, go to some other format. I think Cameron's exactly right. Go to some other format internally, which describes what would I expect out of a query. Start looking at that query while you're talking and thinking about it to see if I get some immediate obvious hits or misses. Add it some background to if I'm Google, the million other queries I got in the last few seconds to see if any of these things are, relatable, related, whatever. But these things all never go to a common sense place. They instead go to, this is a common pattern. This is a thing I've seen before. This is an obvious way. This is only one way to interpret this particular pattern of descriptions. What is A? But if you said when is A, I know there's a time component. Where is you must mean the nearest to me. So I want your location data and shit like that. There's a bunch of these keywords, but that's not common sense. That's a very limited set of things that actually works well with queries, obviously, but I don't know that it goes anywhere beyond that. Like Helix, give me an example of an application you're interested in. What would you like? What's your poster child example? I talk into my phone, I say X, I got an app that did whatever. What's a poster child example here?
So I mean, the example I have in mind is for example, natural language to SQL.
Yeah, okay. So that's been around. People do that all the time.
Right. I mean, I want to try to understand what's the state of the art.
I would go Google that one.
Right. And who are the experts in this field?
Not here.
If anybody know anybody who are interested.
I would start by reading the papers on transformers.
There's I Google and I get a million hits right away.
Right. So I mean, there's a lot of things going on. I mean, myself also do something in the NLP space, transformer, and first of all, you need a language model, right? To extract some vectors out of this.
Yeah. So I would claim that this problem is well understood, and the starting point is to go read. but it also comes with inherently with power steering built into it, because there's a lot of people who can read SQL, and you
Right.
can print an SQL text format. That's sufficient for you to analyze, decide what you intended. You can hand edit the SQL query. This comes with power steering built in. That's a big step forward.
That's right. That's right. I mean, that's also what you mean. Actually, I'm at understanding level of this kind of space. I have already done a lot of homework, and I've started working on something. And in this community, I just try to figure out, hey, if there's anything in compiler space, I also have some kind of things dealing with ambiguity. Maybe I can just marry these two together, and then hopefully come with some new approach to tackle these questions. Right? That's my starting point. But looks like, I mean, compiler is pretty, good at dealing structured language, a structured, math entity, and it's still.
There's certainly an application. If you give it a file, it will immediately spit what's the most probable parse tree if it has learned well. Or this, I believe the interesting point would be the optimization, the neural network that can optimize the generated IR. That would be an interesting field to explore.
Oh,
Right.
Who's doing SSA?
I do need to leave now, but I will type my email in the chat, and then if anybody are interested.
There's a Google Doc that came with your link that'll be live for some months.
Mhm.
That may have some more information for you.
Awesome, that's great. Really appreciate it.
Okay.
Yeah, thank you guys.
Okay,
Yeah.
bye.
Good day. Really enjoyed.
Good luck.
Thank you.
Welcome again.
Will do.
Okay, now I'm playing with Berenstein Bear. Oh, I'm sorry. Bill, go.
No, I just, it's hard. I want to listen until there's an opening. It's like hard to, I just want to mention, I have a topic that I wanted to ask you guys about.
Go ahead.
But, there's two of them. One, I think they may be related. First was just, what is the actual performance saving of a type that just exists at compile time? And then the second one is like, why don't you guys like option types? You, Cameron and you guys.
I'm all happy to rant on either one of those.
Yeah. So
but the other people want to rant too.
So the first one, I think the first one, I just want to know what is the real performance benefit, and what Scala added in Scala 3, an opaque type that really has it never boxes it. So one performance advantage is if it's a primitive type, or like, some kind of value type in the future that can stay on the stack. The stack is probably more efficient than the heap, probably. But
okay, so separate out performance from semantics.
Well, it's just I can give you an example. Like if I have, it could also just be not wrapping something on the heap. Something's already on the heap, like a string. You could say this is an address string. And the only, it's like completely any string is okay, but it's just to keep it from like getting mixed up.
What's the cost
right next to it?
Right. What is your opinion? What is the cost of boxing a string or an int?
That's my question.
Okay.
What is really? I mean, that sounds like it's cheaper, right? I don't box.
Right. Okay. So in most large boxing programming languages, I'll guess that 90% of the expense is in the box. Like a huge percentage of your slowdown is related to the box.
Well, you mean the actual active boxing, not getting rid of it later?
Both the active boxing and using the box have.
So you can see it in the .NET versus Java performance benchmarks. So Java generally cleans .NET's clock by 10 to 15%, except in the collections area. So if you have collections of ints and collections of, I'm not going to say bytes, because bytes are all pre-boxed. But generally speaking, what you see is that Java, first it allocates at a tremendously high rate. Second, its memory footprint is tremendously higher. And third, the performance is sometimes even a factor of 2 slower on these I'll call them micro benchmarks. I don't mean that as an insult, I mean that as it's specifically focusing on, despite whatever the benchmark says, it's specifically focused on the cost of boxing.
Okay.
Right. Yeah, the benchmarks often will say there's something else they're looking at. So the trick with a box is the allocation is extremely frequent, and an allocation in a garbage collected language gets you memory that has never been seen by the processor core since the last GC cycle. So it's a 100% guaranteed cache miss. It must evict something out of your all cache layers to make room for the new thing coming in. And because of the high rate, you churn through it. So you are continuously flushing your L1, L2 caches out to memory to make room for new things coming in, typically with a very short lifetime that will typically get written out and then declared dead and cleaned up by the GC. So the GC cycles will be very low cost. The young gen works, it's cheap and quick. The actual costs are you're flushing your caches constantly and you are running out of memory bandwidth and you're cache missing to bring things in.
Okay. You said that before, Cliff, about
Yeah.
so it's by definition not been seen by the processor since the last CPU cycle. But when you do one of those misses and you bring, what did I say?
You said CPU cycle, GC cycle.
Yeah, because because I'm writing.
By definition, it's
as you're
missing last
talking, and you
CPU
had said
cycle
CPU.
also.
I know you meant GC cycle, but anyway. So let's say I'm going to allocate 1,000 of these things. So I allocate the first one. It hasn't seen it, so doesn't it give me like a section of memory where I'm going to be allocating all the others? I don't have to like do it every time I allocate something, right?
Okay. Yes and no. So when you say a section of memory, what springs to my mind is you get a thread local allocation buffer very early on. Your thread can now allocate it out of that Tlab at the cost in CPU clock cycles of a branch, an add, a compare, a branch. Typically low, you don't keep the Tlab in a register. You're going to load the Tlab from thread local storage. You're going to compare it to some limit. You're not out of limit yet. You're going to add to the base. You store it back.
It acts like a stack, except it only grows.
Well, an arena, it just one way forward. It doesn't go back.
What I meant, you do the same thing with a stack. You do the
Sounds to me
comparison.
like you're both assuming a bump pointer.
It's a bump pointer allocator. Yeah. Tlabs are usually bump pointers. There's a crucial difference between it and a stack. Crucial difference. The Tlab is a new chunk of memory and it got handed to you and then used up, and then you don't use it again, except you get hits on your prior things. But when you allocate fresh, you get a new chunk and a new chunk and a new chunk and a new chunk. These chunks of virtual memory have not been in the processor's core since the last time a GC cycle recycled the virtual memory.
Okay, a new chunk.
Whatever, arena, Tlabs come in, 1 meg to 4 meg sizes, knock on wood, everyone a little different here and there. It kind of doesn't matter.
Can I avoid that by playing free list games and not using a bump pointer allocator?
And people do. And then there's the issue there is you now have the garbage collection language doesn't know when to free. Because he doesn't know when to free things, except when he runs a GC cycle, he can't hand it back to you, right? And this is the difference between malloc and free and a stack. In a stack, the lifetime is well understood by the scoped action of calls and returns in the language.
Yeah.
So you get it back as soon as you, whatever. So now that you've got it back, you allocate it again on the stack. It's sitting hot in your L1 and you're constantly going back and forth hot in your L1. Life is great. If you go to a malloc and free model, the programmer tells you it's free. And sometimes he lies, and that's the malloc free bugs. But if he's got it right, it goes on to a free list and you pull it off. Again, the free list manipulation is more expensive than the stack, but it's way the hell cheaper than the cache miss. And because you're cycling it by malloc and free on and off the list, it's hot in your L1. It gets reused over and over again in your L1 cache. Life is again good.
But to be clear, the stack outside of careful RAI or whatever, the stack has the same problem as malloc free in terms of programmer bugs, because a lot of C developers aren't really knowledgeable enough to understand that when they return an address to something, if they didn't malloc it, returning the address means returning address to something on the stack, right? And sometimes it works because they haven't overwritten the stack yet, right?
One of my early understandings of the lack of understanding was as a young grad student, I helped a senior grad student debug her program, and she had printf into a buffer on a stack and then returned it. And I was looking at her crash dump and staring at ASCII hex bytes scribbled over something else, and was like, You must have done a printf nearby. Yeah. Why the hell is it here? Oh, and then I immediately, diagnosed it. She had no fucking clue. Fine. Not to say women are not women. I'm just saying people lose the model in their head of lifetime management.
So what like if there's a accessing, so if it's a GC language, then that the cache miss overpowers the malloc free, which is why when you needed performance, you reused an object. You have this little pool.
For a GC language like Java.
You take
Yeah.
it.
Yeah.
So for what'd you say, Cameron?
For a GC language like Java.
Yeah, GC
where-
language like Java, yeah.
You could
So
imagine a garbage collector that run every time your L2 fills up, for instance, or your L1 fills up.
Mhm.
People have experimented with these things and they don't typically pay off, although on paper they look good.
Yeah.
And the issue is that the lifetime of enough objects hasn't passed long enough for them to be dead for you to reclaim enough storage to pay the overhead of constantly stopping and running, because you'll blow through an L1 or an L2's worth of memory in milliseconds. It's really quick.
So, okay, what is the real performance savings or cost, of like right now you can only put primitive types, like a half a dozen on the stack on the JVM, and everything else is a reference, which is a real simple model. But like I
That's
can't
not
take an array of two things. Well, I mean, mentally, I can just keep track of.
No, it's not true that you can only put a dozen.
Oh, no, I mean types, byte, long, float.
Oh, yes.
The question is, can you put a
Yeah.
user-defined
put, like,
struct
a
onto the
point.
stack?
Yeah, I can't put two longs on the stack yet. So I have to go, but if I have an int on the stack versus an int on the heap, it seems like it's a lot, is it the cache miss or what is the cost of having to go to the heap?
It's reference as an object. It's reference. It has
Yeah.
to look.
No, wait.
the
You're missing the whole performance.
This is
disconnect
IR.
here.
This is all crushed long before it executes.
Yes,
So
that's correct. The JIT has kicked in,
Yeah.
or you don't care. If
Okay.
the JIT hasn't kicked in, there's your first problem, but then you're not high. Okay, you're
Right.
hot, the JIT kicked in. Okay, what did the JIT do?
I don't
To
know.
the extent that the JIT can get rid of all of your heap references, he will, and
Okay,
make them all fit in registers, and you'll run the super fast way. To the extent that he can't tell where this pointer goes to and what it is on the other side of it,
Mhm.
he has to go do a load through the pointer, and now you're waiting on the data to come back from memory.
right.
Okay, so life gets slower thereby of that amount. So
Right.
as soon as you box something, the cost to go get it starts with an indirect load. As soon as that box contains a pointer to another box, you stagger your loads, and he can't start the next load till the first one comes back.
Right, yeah,
And pretty soon you stack up. I mean, this is where all your performance goes.
I see.
Yeah,
So,
let
Go
me
ahead.
share a funny story here. So in general, I agree with this evaluation of performance impact, but we had a funny story recently. We had a report from a customer which said that they had some utility function which was critical for performance, and they optimized it. And their optimization was that they actually got rid of some of the boxing and some of the allocations. But what they observed is when they updated Zing, they got worse performance on the optimized one. And when I looked into that, it turned out that our pipeline is conditional in some places. And if there are allocations, we actually run more passes there because we want to do cleanups after escape analysis. And these extra passes, they actually optimize their function better if there was an allocation there. And
That's
this,
something you tweaked your heuristics.
yeah. Well, the fix was simple. We just straightened the pipeline in case there are no allocations, but it's a funny impact. They optimized, they removed the allocations, and then it sucked.
Yeah. That's the difference. I think with C2, I just ran everything all the time. I had no reason to skip out on any optimizations. It's not an LLVM based compiler. They all ran all the time. That was useful. Separately, I totally get the problem of, hey, something triggered a heuristic, so we didn't run it or we did. And you get a nonlinear behavior out of your optimizer.
Okay,
If
last.
I understood the question at the beginning,
Yeah.
it was, why is it faster to have the compiler erase types at compile time?
I
than
mean, in
having
a
them live
language,
to
yeah.
run time?
That's the question. Like, what is
There's
the real-
also the whole thing about, did this thing go megamorphic? Are there multiple things that can be called? If there's only one function that can possibly, I'm adding an A to a B, and there's only one function that adds A's to B's in this particular environment. I can do that as a direct call as opposed to having to look at some header and then go see what that object's description is and go find its implementation of that.
Bill's question also had to do with, if I can use this term, type defs, right? Because he was also asking, I have a type, it's still a string. I forget if we box it or not, but I want to call it an address instead of calling it a string, right? So what's the cost of that? What's the benefit of that? So I just want to make sure we didn't lose that.
So
Yeah, that's the question. And it's actually a language feature, right? That Scala didn't have. People wanted it because it's in Haskell. It's called new type, and it kind of makes sense to me. But I'm like, well, most things don't matter performance. And then
so
there's all kinds of stuff going on. And so what is it? What is the real?
If you carry type information off to the side and you never look at it, the cost is almost zero. It's the cost of the disk space to include the type information. Same as debug information for a JVM. You carry debug info in your jar file? You do. Does it impact performance? Not at all, other than the jar file got inflated. If you look at it, then you're doing work with it. Now
it's gone, actually. There's nothing at runtime. There's no information.
I should
off to the side. Don't care.
I should add the types at compile time can result in eliminating more checks that if the compiler can eliminate some kind of checks, it can eliminate it. So to not do it at runtime, that's also a win with the compile time type, for example.
So to the extent the compiler knows more information at compile time, he can totally optimize.
Yeah, you can eliminate the check that if it's not a type, it propagates it as a check in the runtime or something. You can.
Yeah, I see what you're saying.
That's
like let's say you have a positive double or something, and when you pass it square root, you don't have to check to see if it's not negative. If
more likely I have a thing that's declared as an animal, but somewhere early on someone said it's a cat. I now know it's a cat, not just any old animal. And when I come up to the make a sound virtual call, I know it's a cat, and I won't do the virtual lookup and whatever I'll say.
Parser would probably know too if the JVM now gets to use any of that information, because it is loosely there in the class file. The generics are not fully erased. They keep some amount of it for reflection reasons. But it used to be it wasn't used at all. I'm going to assume, Cliff, when you were still there, it wasn't being used for any optimizations.
No, we assumed all annotations were written by an adversary who was trying to break the security model.
That's a good assumption.
Now, we frequently completely rediscovered the generics type info.
Right, that's where you did your original lattice work, right?
Yeah. I mean, it wasn't because of that, but that turned out to work just the right thing. Yeah. And the other thing we did was we made instance of casts against a static known subclass with one clock cycle.
So if I do want to keep type information around at runtime, I either need object headers or I need a V table. Are there opinions in this group of the trade-offs between having a header on every object versus having some V table that every time you call new, you have to stick something into? And every time you call
they're identical.
They're not identical, right? Because sometimes you have this big, massive indirect for the objects, right?
Oh, you have something that gets you to more information about the object. Whatever you want to call the something, a header or V table, whatever, you have something. Okay, what is that something going to be? How is it formed? At Azul, I boil it down to like 18, 19 bits. Now, is it a V table? I don't care what you call it. It's a way to go get more information about the object. The common thing I wanted to do with it in terms of dynamic frequency was make a V call. So I took my 19 bits, I shifted it, added to a table base of all the V call things. I pulled up the V call, I added something else and jumped and away you go. You screwed around, you got something out of it. What is it, a classic Java header? What other people throw other things in the header. Sometimes you have other shit in the header. So maybe you're correct, it's more to it than that.
So it sounds like your answer is both. Have a V table that's off somewhere else and a header so that your header can be small and your V table can be out of the way.
The fight for header bits is long and old and been brutally done by many people. So boiling it down to 19 bits for the class identifier was a big piece of work. That was a big payoff. It let us get rid of the whole extra 64-bit header word. You also had to carry hash code. You also carry GC age bits. You also typically carried lock bits. This is for a Java header. If I'm talking about some other language, I would skip some of those other things, like I'm not going to put a hash code on every possible object and therefore require it in the header. If you want a hash on your object, you write a hash function. Fine. So I can get rid of hash out of it. That was a big pile of bits because you had to have a decent hash. If you had a big heap, you had to have a lot of bits in that hash. You wanted locking bits? Oh, I can probably boil it down to 1 bit to say you can be cheap or you have to go hard, because most of the locks are actually cheap. And if you're going the hard way, you're already going to be expensive anyhow. So fuck it, you lose. vCalls are really common. You need something pretty cheap there. You do need, the GC needs some identifier for what class this object is. The common thing to do is shove bits in the header. You can also do space breakouts in some cases. Like, I'm going to put all my boxed ints in this part of the address space. So I don't actually have to box them, but they can't be everywhere. They have to be only in this space. And then I can look at the pointer to the int to tell that's an int. Shit like that can go on.
So you basically have two different, the way I explained is you have two different pieces of information that every object has to have. It has to have its type and it has to have its identity. So its type is the V table, if you will. Its type is the class header, whatever. Its identity is some combination of information, like the identity of the integer 42 is 42. The identity of the string hello is hello, right? The identity of person P is a pointer into, virtual address space, right? So identity has different, and when we talk about person P, like a more complex user-defined data type, the identity is both the pointer and the dereferenced pointer, meaning it's both knowing how to get to it, but it's also the state within the structure, thinking of it in a C sense. An object is a C structure at a certain address in memory, right? So you basically have a table of 2 by 2, so you have 2 axes. So you have no identity versus identity, and you have no type versus type. So you have 4 possible implementations for any given object at a use point within compiled code. The default way, which is what Java used to do, I don't know how far it's gotten along, but it would always do quadrant 4. It would always have a header, and it would always have it would always have the type, and it would always have the identity.
You have primitives like ints, which had no header and only lived at runtime and were values.
Right, and those aren't.
Those I would say
that's a different type
0.
system. Right, but it's a different type system. I agree with you, but it's a different type system. You can't interchange.
Fine.
Right.
Fine.
So in the object type system,
yes, then it's
the
always
Java approach traditionally was always have the V table, always have the type information, always have the identity information. And over time, they've optimized some of it. So for example, they've got inflatable headers now.
They've had inflatable headers forever.
20 years, right? 20, yeah. But it wasn't in the original JIT.
In the 1.0 or something.
Hotspot, you mean?
Yeah, Hotspot 1.
Yeah, Hotspot. But
Hotspot
the original
1.2 or before, maybe.
Right.
The 1.2
the
had
original, but the original Sun JIT did not have it.
Yes. Okay, fine.
Um,
It was a little weird because blocking was always doing some inflated thing.
Yeah.
Yeah, I don't know. It's been a long time since I looked at the original SunJet. You're right. Fine.
Right. So, but if you knew, for example, so this is where escape analysis comes in really handy. If you know that the object never has to be treated as an object, as a generic object that you're going to call toString and stick in a collection with cats, dogs, elephants, and hand grenades, right? If you're not going to put it in that collection, if it's not going to escape in terms of an RAII sense, right? If it's not going to escape the stack, and in terms of a thread state, if it's not going to escape the thread, then suddenly the code that's executing against it gets to have all the information, for example, about type. So now you can eliminate half the table, right? So 2 of the 4, one of the columns just goes away, right? So now you know the type. You can choose to build the code knowing the type. So if someone says reflection, I want to know the type, you don't have to calculate it. You hard code the answer. It's like It's like when you have a x equals 42 and it's a final int x equals 42, and someone says something about x, you don't have to go look up x, right? It's 42, right? You const expression is what C++ calls const expression, right? Like you're done, right? So now you've eliminated half the table, and in a few cases you can actually eliminate the other. You can eliminate the whole row, right? So when the value is implicit, and this happens with things like enums, particularly you know, low arity enums like null, for example. If type is if the value can only be null, then you already have, you don't actually need type or identity, right? So again, it's
So we have
optimization.
languages like C where the types always boil away. And we have languages like Python where everything's a type dynamic and everything's checking everything all the time and it's consequently slow.
Types
To
always
what
in
extent
C.
can we build languages where some things are in the garbage collected land and some things are, I'm tagging this
Wait,
as
I
a
want to
lifetime.
nitpick. I want to nitpick. It's not about the language.
Yeah.
It's about the
Okay,
implementation.
the C Python implementation where everything's dynamic.
Yes.
There you go.
Java
But
is
who do we know
clearly,
who's made a Python that doesn't have all those problems?
Java's
So-
clearly in the
Can I
domain
tell you
where
about my project?
you got to pick whether you were the primitives and had, or you were not, but half of them had no overheads and half of them have the standard quadrant, what Cameron's saying, quadrant 4 overheads. Yeah.
So C does have runtime types, because C is actually just assembly with macros. I mean, that's what we used to call it before I was born. And so you basically have
You
three
consider
types. You
assembly
have-
to have runtime types?
Yes, you have B, W, and DW, right? What else is there? Like, am I wrong, Cliff? Like, you've got three types.
DQ.
I always added more type depth to it than that, but fine.
But you know what I'm saying?
But it's not in the
basic-
data, it's implicit in what you're calling. Like the
it's
reason
in
you
the
have to have
instructions.
add
It's in the
integer and
instructions.
add float as separate instructions is because the data doesn't know that it's an integer or a float. The
Actually-
instructions have to
actually-
know. The type's
Okay,
been
what are
erased.
types if not instructions to work on data?
Exactly.
That's one viewpoint.
Yeah. Yeah.
So basically, when you're JITting, if you can cordon off the possibilities tighter and tighter, you get to throw away more and more data, right? And that's the goal. That's one of the reasons. I know Cliff doesn't believe me, but it's one of the reasons why we got rid of multi-threading in our design. Like, so mutable data can't be flitting back and forth between multiple threads, because it completely eliminates like one of the biggest impediments to optimization. And it's also the reason to get rid of globals, because globals are an escape leak.
Yeah, I would claim that the multi-threading doesn't, throwing away multi-threading never, in my head, removed a big pile of optimization. Because the JITted code makes very little difference in how it performs in order to support the Java memory model.
Right, but if you cannot escape mutable data across threads, you know, your requirements for even read or write barriers pretty much are gone at that point.
I
So
think Pony had something with a different pointer type for this is
Right.
a thing where all of the aliases are in the same thread, or this is a thing where there exists some alias not in the thread, maybe.
there's a thing there that says I got rid of a class of bugs. There's a separate thing that says if I didn't have to meet the Java memory model, what would my performance impact be on an x86? And I claim the answer would be almost 0 on an x86 and slightly non-zero on like an ARM chip or something. But slightly. And that's because there's not a lot of constraints the model puts on that require you to actually do something exciting about it. It just does require a few orderings of where I lay out instructions, where loads and stores can be laid out. There's not, but not very many of those. And they're not a.
Yeah, but it also requires safe points to do garbage collection, for example.
Well, no, that's a separate issue. Like if I have a non-garbage collector language, I don't care about safe points. Safe points and
No,
garbage
no,
collection do not have to go hand in hand, by the way.
When
So
you
this is-
only have one heap and it's all mutable and it's touched by every thread,
yeah. So
then
Java does
garbage
not
collection.
right.
go ahead.
Java does not require you to have only one heap. So I certainly have an implemented version at Azul that had a heap per thread and a shared common heap. And the heap per thread got garbage collected by itself and didn't need a save point. It was save points were convenient to do it
That's the
at.
type of optimization I'm talking about. Exactly.
Yeah.
Cliff, how did you handle objects when objects had to move between the thread-specific heap and the global heap? Was that copied on assignment, or was that lazily fixed up in some way?
No, it was usually done when I realized an object was escaping. So it was escape detection, not escape analysis. When I detected an escape, I would copy the object to the main heap. It was only single threaded at that point, so the copy was just done by the one guy who was escaping it. Plus all his derived friends, you had to follow the transitive closure and escape them all out.
Okay.
How cheap is escape detection? Does it make sense to do it every time? Or like if you have a for loop and the thing escaped from the for loop 3 times in a row, I give up. I just assume they all escape now.
The only place it ever happens is on assignment.
So having done the practical version of this, the answer is, yeah, you don't want to do it all the time because the act of copying at least is like not a non-winner. And it was very easy to flag allocations that they were going to escape eventually anyhow or not. So, and that was a very strongly normalizing process. So after the JIT had cloned allocation sites, any given allocation site would typically now escape so many stack frames up or to the heap highly reliably with a set number that I didn't necessarily know ahead of time. So I would go run, whatever it took. And then when I escaped something, I went to the allocation site and I whacked it. And I went to the JIT, looked at the whackage at the time he did the allocation, and he changed his mind about how to go allocate from here. If he thought it was going to escape to the heap anyhow, the first few cuts would pay attention and look. And then after a while, I would end up re-jitting him saying, straight to the heap. And then you quit getting escapes. You quit, but you did the detection all the time on objects that were known to be stack local already. And how cheap can you make it? The answer is you can make it pretty cheap. It wasn't like you did it every store up. Well, that's the only place you could escape. You could fold it into the right barrier you're going to do anyhow for garbage collection. Certainly Azul had custom hardware, but the x86 version had to do a check on loop exits, on function exits. A couple of places he did a couple of checks. It wasn't very many.
So the hotspot inspiration I took away from, because again, it was so eye-opening to see it. But, in C++, we had templates, which were basically a form of self-immolation or what's it called when you enjoy pain? Help me out. Oh, masochism, right? So there's a certain state of masochism going on there. Producing bad errors.
Okay.
But you basically had two choices. You either made all types megamorphic, polymorphic, so object style in Java, or you did expansion of code at compile time and produced different executable code for each T, right? For each substitutable T, right? Each form, is that a formal type parameter?
Yeah, don't worry about it.
Yeah. So anyway, but the idea that the hotspot makes so obviously possible is that you could actually do both, right? So not just from a caller point of view, but from a callee point of view, you can produce the same method. So you keep statistics on the way in, and you're like, 82% of the time I'm being passed an array, right? Just a regular old array with shift and add for my access. So I'm going to build a piece of code just to take an array. Now, even though the type at compile time is defined as some generic collection type, I'm going to produce a piece of code to optimize for the array coming in. And then later on, it's like, out of the other 18%, 99% of the time, it's this super duper list that I'm getting passed. So I'm going to create a second piece of code that's going to optimize for that. And now I'm going to create a preamble on, so if someone doesn't know what they're passing me, right? So if I'm in megamorphic world, call the megamorphic preamble, and I'll hand off to the array, or I'll hand off to the super duper list, or I'll go to the interpreted route. That's the hotspot model. So you have the optimization at runtime of looking at the statistics of what's being passed and saying, you know, I'm going to optimize not just the piece of code, but the piece of code given a preeminence of a type being passed. So you get kind of the template optimization, and you still have the generic the unknown, the unknown generic side of it is still fully supported.
And one more fundamental question would be how much of the time you can't know what the type would be, because Rust is all about knowing the types at compile time as much as it can, as much as it can generate the code that what it knows about the type, because that leads it into the earlier question. If the compiler knows as much as it types, as much as specific about some kind of type, it can generate a much specific code. Of course, that it can do this dynamically without blink of an eye, but how much of the code you just don't know what the type would be.
So if you know the types, it's assembly.
Yeah. Well,
yeah, that's a bit of a way to put it. Yeah.
Certainly.
Not all the way, but yeah.
Certainly, it's the case that the profiling costs are low, and if you just start from the assumption that you have some profile data, you right away can make these decisions that say, I have a dominant type. I'm going to split according to the dominant type. And Hotspot certainly does that.
That works really well for your web server that's going to be running for 12 hours. I don't know how well that's going to work for like running a grep that's going to be running for 12 seconds.
It usually pays off in a few seconds. Literally, most of your compiles for most of these sort of modest small apps, the compilation is done within 1 to 2 seconds. They dribble in for a long time, but the bulk of it, the hot code you're going to run to completion, that's over with in a few seconds.
But the other half of it, though, is actually a brilliantly hidden question that I've actually, is why I love this question. It's because the same piece of code in two different, so we think about building things modular and reuse and so on. I use the same piece of code in a couple different applications. In one application, it's always the super duper list. In another application, it's always the array or whatever. Like in another application, it's always megamorphic. It's like I've got 65 different types and no one of them stands out histogrammatically, right? They're all noise, right? And so what the hotspot answer says is, I don't care which is right? I will pick an answer within the context, right? The downside of the Java model is what Aaron asked, which is I'm always starting from no knowledge. But if you can make some of the knowledge stick, or even some of the code production stick,
working on that.
Yeah. I mean, Java's been working on it for years, 10 different ways, and
your suggestion is I save some profiles, I do an ahead of time compile based on my profiles, and then I have the JIT basically rewrite my code from whatever was ahead of time compiled to what's right.
Or I always start with the code that I left off with.
Yeah, you don't actually have to start with ahead of time compile, although you could. If you started with profiles, you could just begin immediately compiling. And typically when a program starts up, it's running single threaded for a while it's reading configuration data and finding all the files it needs to look at and this and that and whatever. You got 20 cores sitting on your box that are idle, or 8 on your laptop that are idle. They can be plowed out compiles.
So the
So I
first
have an
time
idea that
Java,
may be a good and terrible idea at the same time. If you take all that profile data, can you feed it back into the source code? So now I can directly compile the profile data that is in the source code, and someone reading the source code can see, I think this went this way, and 90% of the time.
Power steering, what I was talking about earlier. And maybe
I much prefer the idea. I much prefer the idea that the runtime keeps that all hidden away in its own deep dark closet, right? Like I do not want to see it affect the
I have to play devil's advocate and run with this. Suppose there is a /* comment style that has profile data that the parser is willing to parse as profile and do a little sanity check, and this is all profile data, so it can be evilly, the antagonist can cheat all he wants on it. It doesn't matter. But you could feed it back, and if it had some connection to the source code, you could even tell the programmer, this is what I've been seeing. And, at the same time, when you parse that'll show up as annotations in the jar file that the compiler starts with, and then he profiles new.
That's kind of neat because then you can also, it's first class and you can do tests and stuff.
Yes,
But
and you can
as a
feed back to
programmer, I
programmers and say,
I can't even get my off by ones right. Like, I don't want to see that in my code.
Okay, turn it off.
yeah.
Yeah, we do have this technology where we dump the profile from a run, and then in a subsequent run, we can pick it up and start from there and continue accumulating some facts in there. And we actually do use it for performance analysis. If we have some customer case where like they complain about performance, that's a very useful artifact to understand what's going on in their system. And it's just one single file.
I mean, I'm actually doing this right now. The thing that Cliff was poking at online is I'm doing visualization of compiler passes and IRs and the generated assembly for a bunch of code. And part of it is like, okay, we have the code and its IRs, and then we also have perf data, and I can do a join. And I can say like, oh, all the cycles are on this IR, like it's on the assembly, and then feed it all the way back through, stuff like that. The perf data is not on the public one yet because it's perf data that's not kosher to leak, but it's cool. It's got like a little view. You can toggle it. Not on the public one yet, I guess.
I did it at Azul, and oh my god, it was so fucking popular.
The thing that you were looking at, Cliff, is I didn't write most of that code. That's like cribbed from Go. They have this viewer. And then I went and they generated a bunch of HTML inline in the Go compiler, and I was like, okay, no.
I generated HTML. Yeah,
it's fine, but what if you want the JSON for other things too? So like,
I didn't tell you JSON. We don't fucking JSON. What are you talking about with JSON? I have raw data structures with profile counts in the JVM, and I had a pretty printer that said, go walk and spew HTML for it. And then a little tiny web server that just read a URL and parsed out no regexes, no routes, no shit. He just had a very simple piece by piece parser, and he made links that matched, and then he HTML. There were no JSON.
Okay, I added JSON to this because
and can you
use it for other
can you share? You said that there's some of it available publicly.
Yeah, it's on the link. It's on the doc. It's studentbear.com/SSA demo.
Oh, I was poking at this.
Yeah, that's the thing.
I was going to bring that up. Yes.
So all the things most things are clickable in this. So like you can click a line number, you can click a virtual register, you can click.
Is this for investigating one VM, or could you say aggregate across 10,000 machine cluster and be like, okay, here's what's actually hot in your data set?
Yeah, I mean, the perf annotations are separate from the data. Like
having expanded a box, how do you shrink the box?
Oh, click the title.
There you go.
So we are building something similar for LLVM-IR internally. And yeah, it's what is the IR in the compiler this tool is for?
For this one? Also, yeah. I'm sorry, you're about to hear someone shred a tree 10 feet from me. But this is our internal IR for Cinder. It's a Python compiler. There's two IRs. There's a high-level IR, and then there's like a pseudo-assembly. Low-level IR, both are SSA. Not sea of nodes, like blocks.
Yeah, so what we have at this point is we have basically a split view for, on the one side, you have textual IR. It's complete, like it's something you can feed back to the optimizer. And on the right-hand side, there are different visualization of different analysis. For example, control flow graph, like colored, filtered, I don't know, DOM tree, and there's cross navigation between them. You can click on blocks on the DOM tree and navigate in the IR and vice versa.
Yeah, that's what I have. Are you looking at this?
Yeah, I have it in front of me.
Are you saying it's different, or what's?
It's similar in spirit. Definitely, like we don't have such a nice visualization of the phases. I think that it will be problematic because we have like thousands of them, and usually we look at large IRs, so
yeah, we'll need to figure out something different in order to present that. But the general idea that it's nice to have a tool to take a look what's going on during compilation. Yeah, I think it's very handy.
It's worth spending some money on, or not money, time, energy. When I say money, to get
Let me
your
tell you, the
code.
dump does not handle like a lot of IRs with a huge dump well. It just doesn't. If you try and highlight something that's like a virtual register and you've got like 100 mentions of it, gone. Absolutely not. Like it will just freeze. And Chrome, the time to first paint was so slow, and I loaded it in Firefox and it was much faster. It was like 30x. It's great.
Wow.
And does it have all the phases of the optimizer there, or these are just snapshots at some points?
So we have this list. These are all the listed phases, but sometimes in a phase, we'll have it'll manually run another pass. Like simplify will run our clean CFG pass, which isn't listed here yet, not by name. So we'll just like call it as a function. But the main compiler is just like, okay, get the bytecode, get the SSA, boop, 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 boop. That's all the phases are listed here. Yeah, we don't have anything fancy yet.
Okay. Yeah, I think in our case we have snapshots in the visualizer. We have snapshots before particular lowerings, because we have like multiple passes at the particular lowering stage. But once we're done optimizing at this level of abstraction, it's good to have a view on what's left. Yeah, and looks like you only have textual representations here. I think in my experience, it's very handy to visualize the control flow graph.
Yeah.
It's so much easier to see like where the control flow goes rather than reading the label.
We've got a separate D3 viz it does like a nice dot style thing, and then you can also track registers through it. But also, if you click block names, it'll highlight them. So like you click BB1, BB2, BB0 or something like that, it'll show you, which is not the same, but it's helpful.
I went back and forth on the amount of graphics I wanted. I usually, when debugging, would do a text print only from inside the debugger, where I'm just calling a print function for a narrow region. When things got large, I wanted a CFG, but the CFGs would get ugly, so indenting would get. It was every control flow, every possible failure branch of bytecode that might have a runtime throw, an MPE or whatever, always had an edge out. So you would just get these billions of tiny blocks with a billion edges that run off to sim fail or this fail or whatever. And eventually things would filter back down and the back edge of the loop, whatever. It was way more complicated than it looked. I did a few of them where I did just the CFG. That was helpful. All the ones I attempted where I included all the IR in a graphical format, I never got, because you got big too fast and the graph just blew up in a giant thing. Wasn't.
Yeah, I think because C2 represents everything as a graph. You have a graph of order of magnitude larger, and when you have control flow graph, it's
if I slice it to just the control flow graph, it was sensible. If I included all the bits, it didn't help.
Yeah, one thing which one useful thing in the visualizer we have is that we can filter some parts of the graph. For example, all the paths which terminate with a deopt, I don't care about them when I'm looking for performance, and I can prune some parts of the graph to shrink it and to make it easier to follow.
Oh, that's a good point. I certainly made the graph dumps pay attention to the execution frequencies. And so things that were going to bail off and die got side-armed, and you had a main flow that had all your frequency. But the main flow would still have a ding with a bailout and a bailout and a bailout and a bailout and a bailout, blah, 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 blah. And control flow with multiple bailouts left and right and join and bailout. But we
also use heat coloring for the blocks based on their frequency, so you can quickly see, okay, this is a hot loop. This is something which happens rarely, so I don't bother.
That's interesting. I color coded mine on semantics, not on hotness, but that would have been a good one. Sure.
What dimensions of hotness can you pick? Like cycles consumed, allocations, total memory allocated?
In the internal IR, I took my execution frequency estimate, counting 1.0 as the start of the function. And if you were back cycling, you would be higher than 1. But if you were taking branches that I knew the frequency, I would just do the division. There's an algorithm for sorting this one out.
Yeah, the same story here as well.
Those are fun to play with when you're trying to understand where performance goes and why. At least for straight up whatever. So these days, cache misses count for so much. I'd want to have something that told me I was paying a cache miss cost here all the time.
Okay, can I ask my option question?
Yeah.
Curious if it's related to performance
it's
or why you don't like it.
Yeah, it's related. Oh, you're asking why? Why I hate it?
Oh yeah, why you guys?
Why
both-
do you dislike option as an API?
Always add an extra dereference. Why not?
Yeah.
How could
right.
that slow anything down?
Yeah, it's the same as boxing.
Extra allocation,
And-
extra an object.
And the languages I've used that always made it difficult to deal with the option as a thing that I had to manipulate textually in the code, even if I didn't care. Like I would go to Elms, it's a strongly typed modern language, and it has options everywhere. Okay, fine. So I have a list of things that are known to be options. Well, it turns out that after the first pass, they're really options. I don't fucking clue. Second or third pass in, I'm going to look at a subset of things. I know for a fact there ain't no failures here. But I couldn't tell the compiler, the language, that there were no failure possible. I had to handle a failure case that it couldn't be handled because it was never going to fail.
Right.
So I had to invent a failure mode that wasn't going to happen in order to get by the damn option testing rules.
That's interesting. It's kind of like checked exceptions, maybe.
Yeah, right. Yeah, yes, very much like checked exceptions.
It seems options always seem very artificial to me, and that's the only way I can describe it. Like,
if the compiler can reliably eliminate the option allocation, be it like Rust to reserve a value that it haven't seen and treat it like a non and all the others. If you can, go ahead.
I couldn't do it. I mean, I couldn't do it in Elm. I couldn't do it in some other languages. I'm screwed with options on Scala. I couldn't get the compiler to let it go when I didn't care. And if he was going to box, like this is big data, if he's going to box, I'm dead.
Yeah.
Right. Here's a few trillion objects. You're going to box them. Okay. You're going to just die out of heat.
Right.
Now I've got a thing. I'm pulling something out. It has a not available attribute that says this value is not available for computation. I have to check on it. And if the act of that, the natural meaning of that is to say, box it as an option and carry it forward. If he actually allocated, didn't do escape analysis, he actually allocated, it's death. It's not 10x slower. It's literally can't execute the program at all. So now I had to go fight him tooth and nail to say, if you're going to box, I have to have guarantees it won't. Or I have to say, I do a test for NA. Is NA over here? It's a different kind of a test. If the answer is NA, I do this, else do that, and it's not option anymore, right? I have my own version of it.
A good route would be to eliminate the option for check, for a no check, or for some kind of check.
I wanted a version that either said your options with a 100% hard guarantee that it disappeared, and all the syntactic sugars that said I didn't have to test for option when I didn't fucking care.
Yeah.
Or I didn't have option, and then what the hell is it in the language for?
Isn't this pretty much a guarantee you get in Rust? At least I think it's not even
Rust gives you the
specific for option, but it's like if one of the enum members is zero sized or something, you're guaranteed to get it unwrapped one level.
Yeah, Rust. I mean, no Rust guarantees that. Yeah. In fact, I've just last week, the week before, I looked at that.
I guess the other runtimes just have to do better, right?
Yeah.
Well, if I'm in Rust and I try to read a key out of the standard library map, I get back an option of value, right? Because the key might not have been in the map.
Okay, so Rust, here is the overhead returning optional values in Java and Rust. Blah, blah, blah. And here's people talking about it, but they say they have the zero cost version. I'll throw the link in the chat or in the doc. It looks interesting. I haven't read it very far here. I can go find my window.
Well, one thing that basically when you have a little question mark in your language and it's type checked that it can be null or not, that's kind of an option type. but it's using null.
Yeah.
Just on the
Yeah.
implementation that makes sense, except sometimes you have types like an int where 0 is actually a valid. It's not none.
Right.
So to
Mhm.
make that, you could just add another tag saying, is it there or not, which is fine for maybe one word, but if it's like an array of a length 1,000,
So,
and you
right.
say none, now you've got 1,000 things on your stack and one thing saying it's not there.
So
So-
the H2O technology, whatever, we would have an is in A available for every data type, including Booleans and shit. But we did it by picking a mystery value that wasn't being used on a per chunk basis. We didn't have to do exhaustively.
Yeah.
We didn't tell you what it was, and we could vary it at any time, blah, blah, blah. And you had to ask the question, is in A.
Isn't A, what's is in?
Not available. Is not.
Oh, in A.
In A,
Right.
I'm sorry.
In A.
Imagine I have a list of random 64-bit integers,
Yes, you can have a list.
and some of
random-
them are nuns.
Yes,
If
Yeah,
I
billions and
try to encode them,
yes.
I'm going to spend too much space having a like, is it real or is it not?
That's
So if
the
I say, I'm going to
H2O
pick a
solution.
random 64-bit integer and say, this is my magic symbol for none.
It varies.
And I am going to encode everything as number, magic symbol for none, or magic symbol for, I actually need to use the number that was my magic symbol for none. Now I have to pick a new magic symbol
Right.
bailout.
The H2O fixed this by breaking your data up into chunks of 1,000 to 1,000,000 elements, whatever a good parallel execution size was. Within a chunk of 1,000,000 numbers, there's one more that I can use. It varies
have
from chunk to
1,000
chunk.
1,000 versions of none across
Yeah,
the
it's
chunk.
different ones for every different chunk.
Who picked the number? Who picked the
Look
magic?
at the
number?
runtime behind your back.
So you have to look through 1,000,000 numbers
At the
runtime?
time that I load the data in and I break it up into chunks,
Yeah.
I will compress the shit out of it if I can.
Yeah.
And I usually was highly successful to compress it. While I'm looking, I also found a unique one that wasn't in there.
Interesting.
And it was
Maybe-
actually really easy. You didn't.
How the-
But that does mean I need to take
I
two
kinda wonder,
passes
like-
over my data, right?
Oh yeah. I took one
Yeah.
pass because I read your text form of a CSV.
You took advantage because
And I
you
got a
loaded.
min and a max and some other features about the data that I was using for compression. I usually also then populated a big ass array of longs of the worst case scenario for this chunk. Then I went through that long a second time and said, well, I can all make this shorts, except for use some run length encoding and blah, 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 whatever. There's another pass to go build it out. And in that second pass, I took my guess for what was a unique value and I checked. And
Mhm.
on a rare occasion, I had to go get a third pass to go get a unique out of it that I didn't get in the first pass.
Interesting. Well, the thing that occurred to me is how often do we need min int and min long and I mean,
Right.
double already has not a number, which is none.
Yeah.
So min int and
Oh.
max int show up fairly often. 0 shows up an awful lot. -1 shows up an awful lot. 1 shows up and that's it. No one else uses any other number.
Right. Yeah, that's the trick. People do use max int and min int, but max int -2 is actually not at all common. So that's a first good guess.
So option is not that bad, but the representation of the options at runtime.
Yeah,
is
there's
that
two
bad.
problems. There's representation and there's you have to get out of my fucking way when I want you out of my fucking way. So if I know for a fact that this collection, while it's typed as being option, none of the options are fail. I want to have some short way to announce to the world that costs 0 and a very little programmer writing effort just says, don't do an optional thing on me because I know. And if I'm
Okay,
wrong,
that-
I crash and burn, fine.
Okay, that would work for a primitive, but how about option of a list of an option of that kind of netting of objects? Would it
Exactly.
work?
I've pre-filtered your list. I know now that I want to make a new list that has not the option on them all, but I didn't make it at the time I did it because I didn't want to fucking allocate yet another list of things because that's also a cost. So I have a list of options and for whatever reason, I did some very complicated thing and validated none of these are fail, but I couldn't tell you up front. Now I can walk it again anyhow and copy it to a non-option list at
It's a
some
map.
interesting cost.
It's a map operation.
Yeah, I have to make a
List-
map over it one more time, or I can just know none of these are fail. Now, treat it as a non-fail list.
You mean in the source code, like from?
Yeah, when I'm writing the fucking source
Okay.
code, I had to go deal with option when there weren't no fails possible. And I couldn't without rewriting the list. And I was doing a big data financial text surfing in my web browser. And I'm doing Elm to JavaScript and I'm in a web browser. So I can't do a few million data points and copy them a few dozen times, or the browser just crashes and burns.
Yeah, basically your type was option, and you looked at it and noticed that it was all, you didn't, or maybe you got things that were none, but now you know, but you didn't like transform it.
Yes.
You just know it, and now you want to not have to
right.
it anymore.
The first pass asked the question, and if there were things that were bad, he did a different route and we went another way.
Okay.
Now I'm on the second go round when I'm trying to get ready to convert it to something I want to display or whatever. Power steering is coming up on me fast. How do I declare this whole list of option as ignore the option part, it never fails. So even if I have to pay the indirection, which is already bad, I want to say no. I'd much rather have a version that said, in this magic list, there was a token that I didn't care what it was that said it's a bad thing, or it's a pile of ints, which is the min, the max for the stock product for the day, and the high and the low, and the opening and the close, and the volume, and the I have 27 features on every stock, and I have millions and billions of these fucking data points. Okay, now I validated them all to be copacetic. I want to, in one flip, say, you know, I'm not going to look at and see the NA. Now, if the runtime under the hood tested for the NA value in order to throw a null pointer exception equivalent, I actually kind of don't care if he's fast enough. I, as a programmer, didn't want to say, make a new map because that's an allocation, that's death.
Right.
And I didn't want to say, and every little minor step along the way, if option default to crash because nothing could happen there, right? And that was there's grief in using the option. Whereas if I had a known NA thing, which null or whatever the known NA thing is, I would just do my default behavior. Or if I pulled an NA up by accident and my math was compute the standard deviation, I would compute it with this crappy thing and I get a crap answer. And it's my bad. I
it's
suck.
kind of a NaN. It's a NaN value in the floating point.
Right, it's a NaN value for an int. And floating point was easy. You got a NaN, the hardware propagated the poison along and you got a poison answer out and you knew you screwed up. In the int domain, the NA value, I had to go pick min int or max int or whatever. I picked something. And if I screwed it up and didn't do it right and I was computing geo means, I got an insane answer at the end, you know. And that was okay, I had a bug. Fine.
Well, how much performance? I mean, could your language just say min int is always none? You put a little.
People would hate you to say you can't use min int.
You have to pick a choice by basis. You have to.
Pick right.
Well, there is code you won't be able to port from other languages if you say you cannot use 2 to the 53 minus 1.
Yeah, right. Somebody out there will have picked that value, and their code will not run.
Yeah. Okay.
So
just
we
use
can.
0. Who could use? I mean, the Romans did fine.
Yeah.
I see.
The
So
stock
we can
price is 0 today.
Well,
we
what
can
the
consider
Pythagoras do?
this. Yeah, like
You don't- but in that situation, you don't care if it's checking every time. Is in a. You said so long as it's fast. You said that so.
As long as it's fast, I don't care. And
Yeah,
then he catches me, same as Java does null pointer checks because they're fast.
All right, that's interesting. All right, cool.
And honestly, I just worked around it and said, don't test and I'll just crash. And that's the C answer, right? And God knows people write C code for 40 years and seems to, you know, you get the bugs out eventually, it works.
But even if you did do that check, you're only going to take the branch when you actually find the empty thing, which is rare. You're probably fine.
Yeah, the cost of the check when it's known to be statistically unlikely to appear is very low because the x86 will predict it. And the load compare branch on an x86 is 1 clock cycle. They work hard on that one. If you force the branch to branch the correct direction, you don't even pollute your branch target tables and shit like that. It's literally one of my many, many billions of wasted clocks on an x86. You can't hardly tell the performance cost. Like statistically speaking, if I turned on or off all the NPE checks that Java ever does, you would have a very difficult time coming with an example where you could detect that it was on or off. We did those tests a bunch at Sun because people complained. Range checks and NPE checks. Range checks had a style where it matters, and you can tell. NPE checks, you can't tell, not with any statistical significance. It's so fast.
So this is, I think, float typing, like with a null check, and then inside the curly brace of that if where I check for null, I know that it's non-null and I don't have to put the question mark.
Yeah.
That way you're just dealing, even though it could have been null, you already checked it wasn't. And what you're taking is that same variable and you're making it more narrow, like it's like lower down.
Yeah. I want to
take before, but now it isn't.
That is a flow typing. That flow typing can describe this for you.
That's
I
what,
want to replace it from, it
Yeah.
might have been an option I should handle, to if it's is an option I should crash, and no extra syntax to be written. I don't write any syntax, but the theory is, just like in Java, you screwed up, you don't get a crash, get a null pointer exception,
yeah. Yep.
which has
okay.
well-defined semantics and blah, 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 and, you know.
All right, cool. Well, that's helpful. That's different than I wasn't sure why you guys. Is that the same thing for you, Cameron? Other than you just said allocation.
It's not quite, because but it's in the same ballpark. It's kind of, he and I are working on two different axes. You know, so I think specifically of the option type as being something that is used vis-a-vis using a union, what's called a union type.
Yeah. Yep.
So so basically Cliff's description is a union type over a 64-bit domain where one pattern is a type called NA, and the other pattern is called NIT, right?
Yep.
Is that a fair description?
Yep.
And you know, and that's, I like the union type approach. I mean, regardless of the low-level implementation, but it does have, for a type-safe language, it does have the programmer overhead of having to be aware of the type. So narrowing, you know, the question of how do you narrow for a variable is quite easy, but for a collection of stuff where the collection is also well typed, that's a harder problem. And that's the one Cliff was complaining about. So I don't know if I have an easy solution for that problem.
Okay, cool. I'll think about that.
How do you pick the underlying representation that makes sense? So if I have like an enum of zip codes and I have an enum of cities, and now I want to make my tagged union that says I am a city and this is the city, or I'm a zip code and this is a zip code. But in fact, if I add them all together, it's still going to be way less than an int 32. So I kind of just want to make one bigger enum. Rather than a tag field and then the int from the enum.
The H2O thingy was columnar compression for performance because of bandwidth savings. So I'm not going to run your enums for your San Francisco cities with your zips. They're different enums, and therefore they compress differently, and I'll get a better compression out of it, and that'll turn in performance. In the case of either one of those, well, the zips, I have a pile of numbers. I don't necessarily know their zips. They get down, they range from 0 to 10,000. There's a free one. If it's 16 bits, I got a 16-bit representation, but not an 8-bit. And there's not necessarily a usefulness to going to like a 12-bit, or it's more cost. So I'll just skip. So you got 16 bits, you got a spare one, done. Right? In the case of a string that's being converted to an enum, like the cities, San Jose and San Francisco and, you know, Detroit and Dallas, whatever, that mapping always starts with the assumption that I can have a missing guy and I'll give him the 0 enum on purpose. And everyone else, I'll pick an enum for them that I won't tell you what the enum is, but I'll have an enum string mapping. So from your point of view, it's a string column that I'll tell you, I turn it into.
And you're just building up a value table on the side.
I pick up a value table on the side, compress the shit out of it, yes. And then the many of the algorithms that you run want to treat it like an enum, but they don't really care what the enum value is. So you know, you love the fact that it's an enum in terms of how that algorithm works, but he doesn't care that it maps San Francisco or San Jose to 17 or 32 or whatever. So pick a number.
And it's only when I go to print it that it goes, oh, wait,
yeah. No,
where's
I
my
go the other
value
way.
table?
No,
I need to turn this thing back into a string. I'm trying
yeah, you turn it. Yeah. You do all the right magic under the hood. In fact, the nodes parse in parallel and distributed. They don't know each other during parse time, so they build up different enum values for the same strings. So there is a pass at post parsing where they correlate the tables and get them all to line up with the same values. And then they have to go back through and recompress their enum columns with the new table mappings, but that's a part of the complicated of the setup. It doesn't cost you anything that you can notice when you do this. You're way over dominated by disk time than you are by running another pass over the data.
So is that going to be your demo app to prove out AA is re-implementing an H2O like thing?
Probably, I don't know. I got down this path because I found it was annoying to do data science in H2O because I couldn't get a good Java interface going. And that was the limitations of the Java language. But I liked the fast, quick, easy math for doing fintech analysis that I got out of H2O.
I do kind of like the idea of the first AA project being H3O.
I could do 30 years of financial, look at all instruments over a 30-year backtesting history, building a model every day for the high, low, min, max kind of things in a few minutes on my desktop.
Is that
So
deuterium?
I'm sorry?
The H3O, is that deuterium?
I don't have an AA, so I don't have an H3O.
No, the heavy
You
water.
were speaking
Yeah, it's heavy
the
water.
element. Yeah.
We had so many water puns at H2O. Oh my God, there are a lot of them. It started out because we did a redundant array of inexpensive nodes as a playoff of RAID. And then we got into the water thing as, oh yeah, there's a whole lot of things we can screw around with here. Yeah. So there were a lot of water puns internally to structures and layout and things, but it started with rain. That was back when we were doing the, you can add and drop nodes, same as RAID, and still do math computations. And that turned out that'd be uninteresting. Way more exciting to do data science in general. And a handful of nodes could handle very large problems and were highly reliable, so you didn't really care to handle dropouts. Unless you're doing supercomputer exascale shit, 100 nodes will run for a few hours with reliability approaching 1, and I can get a day's worth of work done. And if I have 100 nodes, oh my God, I got high terabyte counts. If I'm doing high exabyte counts and I need tens of thousands of nodes, now I got to handle dropouts on a regular basis. But if I'm coming to a data scientist, I'm looking at people doing R and fucking Python, and I tell them your laptop can do a 10 gig data set, and they look at me cross-eyed like, what? I can't do 1 meg barely. Oh, I can kind of sort of giant laptop scrape close to a gig on R or Python. And I'm like, my laptop, same as yours, I'll take high gig counts and be done in fractions of a second. And they're like, no, and I demo. This was the sale. This is the H2O sale. This
is what awk is for.
Yeah, except I'm faster than awk by count of cores. You think I'm laughing, but I'm not.
I just chime in for the occasional shit post.
Yeah, fine. I can do, we did logistic regression, not linear regression, logistic regression on a 7 terabyte data set in 90 seconds on a cheap ass Amazon cluster. It's a minute and a half for a logistic regression on, fucking, order magnitude 10 terabytes.
So years ago, they had that terabyte sort competition or
Yeah.
whatever.
Oh yeah.
And I was like, really? So, 5 minutes later, I had a terabyte sort that was done in a fraction of a second.
Okay.
I was like,
So
well,
we
that's
totally.
the record. But then the problem was you actually had to move the data across the network, right?
Yeah.
So like your time to first key was 100 milliseconds.
No, yeah, right. That didn't count. We got that for
Right.
free. Fucking when you load the
Exactly.
data, we did min, max, standard deviation, a bunch of things on the data at the cost of loading it in.
No, I'm not talking natural sort. I'm talking specific
Oh yeah, right.
custom
Yeah.
sort
Yeah.
given
Yeah.
right then, and you have to resort.
Right. Yeah. We implemented that Terra sort, and it does pay attention to network traffic and shit. But the first element could be available pretty damn quick. Yeah.
Instantly, right? Exactly.
Yeah. After that, you got to do
Yeah, because basically the only things what predominates the time to first key is actually GC.
Oh, not for us. That's interesting.
So
Why?
when you have, say you have 10,000 nodes.
Yeah.
And
oh yeah, I never did it with 10,000.
Sorry. Say you have 1,000 nodes, each on 10 cores. So you have 10,000 partitions.
Yeah.
I'm just making up numbers, right?
Yeah.
So what is the chance that one of those is doing a GC when you ask for the first key? Because they can do the sort in basically 0 time. You give them a function, they do the sort in 0 time, but that's 0 time if they're not GCing.
Right. And the answer is, if you're asking from an idle cluster, 0. They will not be doing a GC.
Right.
So for
but if
demo
you're
purposes,
in a busy cluster.
Yeah.
So in the way you solve this, which we didn't implement, at least not while I was there, is you fire every request twice. So you fire it to the primary and a backup.
Yeah.
And so if one of them is GCing, the other
same solution for what I talked about earlier, the failed nodes. You can't tell the difference between somebody who's not responding because of GC from a node just failed on you. So we started on the path. We actually had a version that did all the things you're talking about there on small, like we didn't have all the algorithms yet. It was very early on. We were doing a fantastic key value store, and the market for key value storage was saturated. So we pivoted to machine learning and gave up the redundancy. Yeah, right. Well, I still, HO still internally runs a key value store I claim is as fast as one I've ever seen. And I looked hard and measured fast. It's really fast and has Java exact memory model consistency semantics, and it's as fast as the fastest ones out there. And it does not do redundancy, which I think wouldn't slow it down to have redundancy if you didn't have a failure. If you had a failure, you'd have to have whatever the failure recovery was going to be. So it can be done, but no market, not for us. Machine learning ran away. All right, here we are. We're at the usual 2 hours and change. We're winding down into random Cliff bullshit stories. It's time to ponder.
Quick announcement then. I finally landed the function inliner. Now you can inline in Python.
Your Python jet will inline.
Yeah.
Yeah.
Not in C Python.
Is that indentation specific?
Exactly, right. So it's really hard to, it goes to the file and it has to scan linearly to the starting line, and then it goes through and it puts those in. It has to indent one chunk. And then also it has to go do a renaming.
Oh, you mean for
this is in our IR. Come on.
This is the IR. Yeah. I did a lot of work to make my IR pretty print with inlining smarts up to a point, and then I gave it up.
Ours says begin inline function chunk and inline function.
No. H2, C2. I mean, it's a full-on optimizer, so the inline bits like explode around and get CSD'd into all the different other places and disappear and come moved out of loops and all kind of shit. So sometimes you can blame a particular guy on he came from over there, and sometimes you couldn't.
We don't have any of that yet.
But I didn't.
Do you
I
have
didn't have
public
any.
benchmark numbers yet?
Fine.
Yes, and
What can you say relative to PyPy?
it's so PyPy for numeric kernels and stuff like that always wins, because it does the trace and it finds the hot loop and it like unrolls and it unboxes and everything. For short-lived benchmarks or things that involve, like, the big thing is if you need a Python that also does C extension stuff, PyPy is really hard. They're working on it and the HPy team is doing a great job. But right now the support isn't there, which is why this exists. But the benchmarks we have somewhere. They're not like, there's this guy, Stefan Marr, who does benchmark shootout of all the different languages and a couple different benchmarks, like the Smalltalk, the Java stuff, the whatever. And we want to eventually get.
Put in the doc link.
Oh yeah. Are we fast yet? Is what it's called. Oh come on! Don't start again.
I have read it. Are we fast yet?
Did you already add it? There, I got it. Oh, I don't have edit access. No, I do. Okay. So that's the are we fast yet? And then we have some kind of benchmark in the, so the thing that is the most interesting probably is that right now, if you want to make Python fast, use this thing called Cython, and it takes Python-esque stuff and it translates it into C extensions. We have our own in-house thing. God damn it. We have our own in-house thing that's like Cython, except it's managed, and we can still translate it to like, damn, it still goes through the optimizer and it's like all that stuff, and then it emits really nice assembly. I'm gonna mute. It's called
You gotta
static
quit having
Python.
trees out of your window, obviously, unfortunately.
It's the neighbor even. It's not even my landlord. It's like the neighbor was like, we need to cut down some branches and mulch them right fucking now in the middle of a pandemic workday where everybody's working from home.
Yep. Yeah, fine. It's happened to me too. Fine. Across the street in front of my house.
Congratulations, Max. That's pretty cool.
Yeah.
Not the tree thing.
Yeah. I want to get there too. I'm so tired of working on this theory piece. I got it correct now. I'm doing performance shit on it with this damn hash code and cleanup of all kinds of year and a half of ugly mistakes.
You can try to prime how fares as a hash code. That's the JavaScript implementation.
Did you ever
Has-
figure out the precedence?
Me?
No, Tidor with the parentheses, remember?
Oh,
yeah.
No.
Because I'm curious.
Mm,
Because I would
um,
have assumed that the bit Zor would have been the lowest precedence.
Well, I'd
so
go ask
multiply.
JavaScript precedence, and we were multiplying and zoring, right?
we can probably find out
Wait.
if
Are you saying there's specifications for that language? Why did I never know this? I thought
Oh,
JavaScript was not specified.
ECMAScript.
ECMAScript. Yep.
I just figured every time I ran JavaScript, there was a random set of rules they were applying.
I pretty much.
But it could be me. I mean, could be my bugs.
Could be, could, maybe not. Oh God, it's got 15, 20 entries in the table. I'm still hunting. Multiply somewhere in the middle.
Oh.
Where you had multiply, you had Zor. I gotta fucking find Zor.
Yeah, I just looking at the table, and the precedence table has 19 different levels.
Yeah, Zor. Okay,
Fine.
so Zor is level 7 and multiply is level 13. Now, is that greater or lesser? I think multiply binds tighter than Zor.
I believe the lower will bind tighter.
You think Zor will bind?
I don't think so. Number 2 is assignment. I think that should be one that's least
Yeah.
binding thing.
And grouping, parent grouping is binding the tightest at the top. So I claim your Zors are happening later and your multiplies first, which means you could fold the multiply to a constant.
Yes.
And your thing is multiply this plus constant that or something on that order of magnitude. There's something simple there.
So you said there's 19 levels. So
Oh,
how
and
many
then
of
you're
them, how many of them are different equality comparisons? It's like 5, right?
Yeah, 9 is an equality comparison. If we're equality and strict, 10 is less than, greater than, instance of. There was some other comment about truthy at the head of this table I didn't look at. The ors and ands and ors and no coalescing are lower, ternary is lower. Assignment, including operator assignments, are all the same, right to left, very low. Commas at the bottom. No, there's only a couple of truthy test levels. I think truthiness has a weirdness to it, independent of its where you level with it. That's like, am I truthy or not according to I'm an empty string or I'm a 0 or I'm a,
Right.
I don't know what the hell.
No, I'm looking now. That you weren't joking. It was 19 levels. Holy cow.
Yeah, I'm currently struggling to get the personal stuff I'm working on down to I think 7 or something. Because
yeah.
I think it's like if you need a table, then you've already lost. It's like 7 can be kept in the head, but more than that, it's.
Well, I claim I only have 5, but I'm also cheating, and I don't have all the operators I'm probably going to end up with.
That's true. Yeah, it's interesting in which direction it pushes language design if you are trying to eliminate as many operators as possible, and I think it's generally an interesting, if not a good direction.
Yeah.
I just looked at ours, and I'm not going to say anything else. I'm not gonna insult anyone else.
Is it more or less than 19?
It's less, but not enough. Not an order of factor of 2 less.
Which one?
Excellent.
Ecstasy has 15 levels.
Oh, damn.
But the ones at the edges are not used really.
Yes, exactly. Same as JavaScript. They're not used, but they had to be mentioned. A comma at the bottom and parent grouping at the top. Okay. But how about, member access or new? Post increment, got to have that.
Right.
And or not unary plus, unary minus, separate from other kinds of minus and pluses, prefix, post, prefix, increment, decrement. Postfix increment and prefix increment are at different operator levels.
Holy cow.
I don't want to see the code that depends on that little fact.
Yeah, best not to even offer it. It's like
yeah, right. Well, say plus plus x plus plus. Which
Yeah,
what is it?
it's, don't offer
I
it.
think that's undefined
Don't
behavior
support it.
in C. So like,
Oh, in C, it's well defined in JavaScript. It's well defined in Java, but I think it's left to right.
Hmm.
I think you get to add it, and you're going to add it again. So the meaning on X is well defined, and the plus plus is the result, and then the extra, the trailing plus plus, is not the result.
So we should talk precedence next week, because I spent a lot of time
Sure.
on that one. Basically, every
Absolutely.
time I was writing code and I was like, why do I have to do this, or which should I do, or whatever, it's like I would like collect all that information. Like I was a precedence,
yeah.
I was a precedence table hotspot machine, right? I was trying to get it to the point where I would only have to use parentheses for something weird.
Therein lies the fault. I think minimizing parentheses is not the correct answer. You want to maximize understanding when you read it.
Right.
And as soon as life got shit weird on you, I wanted parentheses, even if it was well defined in precedence.
Right. I have no problem with extra parentheses to make a statement,
Yeah.
for example.
Well,
right.
Right. But then go left to right.
But
okay, not quite, but yeah. Multiply and add are well understood. And or, I don't want to have a lot of extra parentheses around. But if you mix ands and ors in the same level, in the same row, I want parentheses. So if I say A and B or C, what order did you mean? And in my head, it goes too many two ways too often, where and should bind tighter than or kind of mathematically, but I kind of want to say that's a syntax error. Put fucking parentheses in there, dude.
Right.
And left to right is almost surely wrong. Say A or B and C. That's left to right. Almost surely.
Python.
Sorry, go ahead.
A less than B less than C.
No, we did that one. Cameron and I talked about that one. We've agreed on that one.
I love that. I love
that one. Actually, it's very confusing.
Is it? Why?
Because it does A less than B and B less than C.
With evaluating B only once.
Exactly.
A less than B.
It's all operators. It's not just less than.
No. It's there's only a limited set you can do this with.
Yeah, you can only combine less than and less than equals and greater than and greater than equals.
In Python?
No. In general,
in any rational language.
Okay.
I threw in the instance the semantic meaning of A less than B less than C. And I would claim that you could also do this is well defined, and with greater than is well defined. All well good. And then this one.
But is it worth it?
Oh yes. The readability is really nice for this one.
Yeah, I use A less than B less than C. Fair enough that I would like that form. So it's
so what ends up happening?
It would seem that the function is parenthesis is this one, the first. I have to double check, but it produces the same patterns. If you switch the parentheses, the pattern changes.
Which one?
In the chat.
Oh, I'm looking at chat. The chat.
Mm-hmm.
So Simon, back to your question. So we often have, assert 0 less than equal I less than size.
Yeah, right. Yeah.
So I have an index passed in 0 less than equal to index less than size. And it reads beautifully.
What's the percentage of if expressions that make use of that in your experience? Sorry?
Somewhere between 1% and 3%. I mean, it's pretty low.
And
yeah,
that's a point I'd argue. It's making like the 1 to 2 or the 1 to 3% much nicer to read, but it adds the mental overhead of being on the lookout in the 97% of the cases where it's not even used.
I expected that. I really did expect that, and I was wrong. So I voted against it initially, and then as soon as we had it, you just take it out of my dead hands, right?
It looks good to me. I don't have any overhead looking at it in my.
I was surprised, so Simon. Like it's anecdotal, but we have that one has not caused any complaints. It was one of the more popular changes we did.
Okay. Interesting.
Yeah, I'm surprised.
And
Yeah,
somebody
it's,
said
it's
doesn't apply or does apply to, it doesn't apply to any other operators that I
Yeah,
know.
and it may actually be one of the things that got inspired from a conversation on this call. Like I took it
was.
away and I said, well, I'll prototype it and see. And like, and I was like, this isn't bad.
I remember you and I going around on it, and then you said, I'm going to do it. And I was like, cool. And then you said, it's awesome. I was like, oh, wow, cool.
Yeah.
I'm ready for it when I get done
So
with my
not only
theory
was I
bits.
not expecting it to be a keeper, but after I put it in, the guy I worked closely with here, he didn't think he'd like it. And then now he uses it everywhere. So
I certainly see that expression in exactly your range check case, a bunch of places. It shows up.
it shows up much more in asserts than in ifs for whatever reason. Like
Certainly where I'm using it now. I mean, I don't have it, so I have the fake version. I have a few places where I have it, would have it in ifs, I think. I have some of these funny graphs hunt search algorithms that do stack of back edge, forward, whatever, that have limitations on ranges. But I have a lot of them that say I have a range. I have an array list variation and I need to do a range check. And there it is. Google Docs. Oh yeah, fine. Well, okay, so once more, I will make an effort to cut it off at 2.5 hours. 15 minutes of, I don't know what, range checks and something else.
And parentheses
And
around JavaScript.
parentheses. Operators,
Parentheses.
19 levels for JavaScript. Oh my God. Fine.
Okay.
A good meeting. And God, we have a big party stuck to the end here. So till we meet again.
Thank you all.
Bye.
Bye. Bye.